Hello everyone. Hey guys, can you hear me? Hey guys, can you hear me? Can you hear me well? Okay, that's great to know. I hope you can hear me. I just saw a comment that you guys are not able to see the notes of the last class. Is that the case with all of you? Guys, are you not able to see the notes of the last class? Are all of you not able to see the notes of the last class? Okay, that's strange. Actually, I did upload the notes after the last class. So if you're not able to see the notes, I will get in touch with the Scala support team and will try to fix that for you. So I will take a note down. I will note down that this particular point and I will try to get this fixed because the notes are uploaded. It is only available only inside recording, not available outside. Okay, Tarun. Thank you for sharing this update. I will get checked with the Scala support team and the note should be visible to all of you. Okay, cool. Kshitij, yeah. Okay, guys. So let's talk about the second biggest concern that you guys might have at this point in time. We don't have a WhatsApp group for the batch just yet. Now, the reason actually is that WhatsApp has been banning groups of Scala over the last couple of months or so. So that's the reason why we don't have a WhatsApp batch yet. But the idea is that we are going to create a Discord channel. I'd already requested the Scala support team for the same, but I have not heard back from them yet. I will, after today's class, work with them again and try to get that sorted because we need the Discord group so that we can continuously talk over that group. So allow me a day and I will try to get that fixed. Smita, I will talk about this probably. Okay. So Smita, I hear what you're saying. I will try to see how early I can end. But yeah, I cannot promise a hard stop at 11:30, and I will try to end the class as soon as possible. So I hear you, and I hear a bunch of others also in the class who might want to complete the class a bit early. But I hope you appreciate the trade-off involved. That either we try to reduce what we cover, or we try to end the class, or we let the class go on till let's say 11:45. But anyhow, we'll try to cover it, complete the class as soon as possible. I hear you. Okay, guys, cool. Is my screen visible to all of you? Guys, are you able to see my screen? Akshay, that's not entirely in my hand. As I told you in the last class, I will anyhow be trying to take a few extra classes, but still, in order to complete in the depths that I want to cover, 11:45 unfortunately comes out to be the time, and 11:30 becomes a bit too difficult. Okay, let me go to the notes of your class. We have seen notes of another class right now, so let's go to the right segment in the notes, and let's very quickly look at what were we covering in the last class. Okay, in the last class, my dear friends. Okay, so we learned about that what high-level design is, and then we went on and saw that if you want to build a system that can really that you can put out in the world and people can access it, what are the different things that you will have to set up, and what all things there are going to be required for that system to be visible by the outside world. Okay, so let's draw that diagram very quickly and let's continue our discussion from that point onwards. So I want everybody in the class to pay attention. Cool. We just saw what we got in the last class. So today's date is 17th December. Yeah, guys, I hear both sides of the class, and we will probably discuss a bit more on this towards the end of today's class. For now, let's focus on the content at hand. Okay. So, okay, my dear friends, in the last class we saw that if you want to build a product that you are going to make available for the outside world, let's say we were talking about this example of Delicious. Now, can all of you tell me what all components are going to be required for this product to become available for anybody in the world to access it? I hope all of you will be able to point out that the first component that you require is going to be a public IP. So I need to lease out a public IP. So let's say I do lease out a public IP, and now I have a public IP on which my machine is listening. Then second, we said that we are going to require a domain name. So let's say I acquired the domain name Delicious. So that second step is also covered. The third step that we mentioned, my dear friends, that you need to do a DNS mapping. Basically, you need to map that hey, that I can know, which is the ultimate source of truth on DNS. That hey, whenever anybody asks for Delicious, please map that to this particular IP address. Let's say IP-A. This is basically the address on which my machine right now is listening. Is everybody clear on these first three steps? These are the first three steps that you have to perform so that people across the world can communicate with you. Okay. Now, my dear friends, let's imagine that there is a client, right? Let's imagine that there is a client that wants to access this. So let's say there is a client in some part of the world that wants to access this website. What will they do? Let's say there is a student sitting in a college dorm and he wants to bookmark some of the interesting websites that he come across. So he will open his account, but before that he will open the browser, and in the browser he's going to type Delicious. The moment he types Delicious, my dear friends, then you will recall that you will go to a hierarchical DNS resolution. You will first probably check whether my browser has the value of this particular IP of this particular domain. If not, does my operating system have the value of this particular domain? If not, then does my neighborhood router have the value of this particular domain? If not, then probably I will recursively check in the DNS and ultimately get the IP address of this domain name. And now when this particular domain is going to become popular in your neighborhood and more people are going to access it, ultimately different levels of the cache will get populated. And for the follow-up or the following users, this resolution is going to happen a lot faster. Is everybody crystal clear on the line that I just said? Is everybody crystal clear? That's basically one of the takeaways that we had from the last class, and I hope all of you are with me on this. That's great. So now once you get the IP address through DNS resolution, so I can draw an arrow like this, that hey, your client will reach out to DNS. It need not be the ultimate source of truth DNS, but that entire picture of DNS can be represented by a single arrow, that hey, you will recursively go to different places and ultimately find the mapping, and that DNS will give you the IP address back. So once you get the IP address from the DNS, the client is essentially going to make a normal HTTP call on that IP address, which means that no matter wherever the client is, the internet is somehow going to forward that HTTP request to the intended server, because that intended server is the machine that is listening on that particular IP. So now somehow a connection is going to be established. The client is somehow will be able to reach out to the machine where Delicious is running, and the HTTP call is going to go to the machine. Okay. So it seems my cat, who attends all my lectures, today wants to show her face also to you guys. So allow me a minute. Let me ask my cat politely to get out of the room so that we can focus. Or she can choose to sit in my near my legs so that she doesn't disturb me. Let me see what is her mood. Is she going to disturb me again? Probably not. So I will give her another chance. If she disturbs again, I will show her the way out. Okay, cool, guys. Anyhow, let's continue. So the client is essentially going to make the request to Delicious. Now, my dear friends, we discussed that back in the day that in that particular class, that let's say the guy who wanted to start this website Delicious just hosted this out of his own laptop. Okay, so let's, for the sake of, to understand that to begin, probably that guy just wrote some code and hosted out of his own laptop or his own personal computer, and the IP address and the domain names are sorted, and now his own computer is actually listening on the IP address. Is everybody clear? So let's assume that right now this guy actually started hosting this out of his own computer. Now, my dear friends, what really happened, and I'm telling you a real story, this is the real story that really happened, that this website back in early 2000s, roughly 2003, 2004, once this was launched, just like Facebook happened that it went viral college to college, similarly, this website, when was launched from one particular university campuses in the US, this website all of a sudden became a rage. So what really happened is that the user base started to grow rapidly. For example, you can imagine that originally, or in the first month or so, you would have gotten, let's say, 100 users, but then from there on, once the word spread, the user base started to grow rapidly. So let's say 100 became 500, 500 became 1000, 1000 became 2000. So week over week, the number of users or the user base was growing rapidly for this particular product. Now, my dear friends, remember that you started hosting this out of a single laptop. Think about it. Do you anticipate that there are going to be scaling challenges or challenges which are going to come by when the number of users grow if you are hosting your website out of a single personal laptop? So I hope all of you appreciate, and let me count this as a line so that all of you appreciate this even better. So what I'm wanting to say is the following: to starting by hosting the website on personal laptop is fine. However, Delicious started to see a lot of increase, or I will say, in fact, rapid increase in the user base. And when you start seeing a rapid increase in user base, and when that happens, scaling challenges emerge. Now, to make this more clear, what kind of scaling? Okay, sure, Akshay, I will take that suggestion and we'll keep that in mind. Okay, thank you. Anyhow, now when the scaling challenges emerge, my dear friends, think about what all scaling challenges can emerge. Things like that, hey, my CPU, so my machine essentially has a CPU which is doing all the processing. So my CPU or my processor might become a bottleneck. Is that making sense? So what is the processing power that my computer has? If I have more than X number of active users, I will require a higher processing power. And now my CPU or my processor might become the bottleneck. What else can become the bottleneck, my dear friends? I told you the other day, every machine has a network card, right? Okay, so give me a minute. Okay, give me a minute. We will ensure that our cat leaves the room. Guys, give me a minute. Yeah. Hey guys, I am back. Can you guys hear me? Can all of you hear me? Cool. Okay, so we're talking about that. Hey, your network card can become a bottleneck because no matter how good your internet connectivity is, but your network card essentially creates a limit on the amount of traffic that can be transferred per second through that network card from the cable or from the network to the machine. So the network card becomes a bottleneck. What else becomes a bottleneck? You can argue that your storage becomes a bottleneck, because think about it, right? If you are Devendra, we can't increase it unlimited. Are you saying that your network card cannot become unlimited? Is that what you're saying? I am just saying that the present machine, whatever network card comes with it, probably is not going to be able to scale up to the amount of load that you really want, and that can become bottleneck. Okay, what else? Your storage can become bottleneck, because with more and more people who are becoming your customers, and every customer storing their own bookmarks, how many of you understand that every new user account and every new bookmark that they create is going to essentially add more data load or more storage load in the machine? And given you're using your own personal computer, your storage also is going to become a bottleneck. Now, what else? We have talked about the processor, the storage. We'll talk about the primary memory as well. So, how many of you, primary memory can be just considered as RAM, for example? Now, how many of you understand that whatever data processing your processor does, or whatever computations your processor does, it requires the data to be present in the primary memory? How many of you appreciate that? The processor is not going to work directly with the secondary memory. The processor is not going to work directly with the HDD or the hard disk. The processor would want copy of that data to be copied from the hard disk to the RAM, so that the processor can interact with the data that is present in the RAM, which means your physical memory or your primary memory or your RAM might become the bottleneck. What else? So all of these things and many others can become a bottleneck. And one very important point is that you will have a single point of failure. In system design, we call a single point of failure as SPOF. So given that all of your processing, all of your storage is being done by a single machine, that single machine can become a bottleneck for you. Because, for example, if that machine restarts, your service is going to be down. Nobody will be able to connect to you because you are just based out of a single machine. If your machine runs into an error, then nothing really can happen because you have a single machine. If the single machine is down, your entire service is down. So how many of you understand that you're introducing a single point of failure where a single normal machine that you have is doing all the serving, which means if the machine goes down, everything goes down. So guys, these are the major issues that can come up, or major bottlenecks that can come up, or scaling challenges that can come up if you essentially have been hosting your website out of a single machine, which is a normal computer. Now, my dear friends, is that clear to everybody in the class? Are the scaling challenges clear to everybody in the class? Can I have a bunch of people who can say yes to this? If this is absolutely clear. Okay, great. Now, guys, if this is absolutely clear, let me tell you that this is not a problem unique to Delicious, but this is a real problem in every system that you're going to build. Okay, Chip, let me tell that. But let me complete my flow. So any system that you're going to build in real life, beyond a particular scale, scaling challenges are going to emerge. And we are in the next section of the class going to look at how do you target your scaling challenges, or how do you handle your scaling challenges? What are the different ways to do it? We are going to talk about that in the next section. Now, Achyut is wanting to understand. Tarun, can you explain why network card can become a bottleneck and why RAM can become a bottleneck? So let me answer both of them one by one. I will take a quick detour where I will sort of go outside the flow of the class, and I will talk about these two things so that I can give you some more understanding. So, my dear friends, if you understand how computing really works, please understand that, let's say this is your place where your actual data is persisted. So, for example, If you store a file, let's say, or let's say, okay, so let's say we are talking about all the data that you have stored in your laptop, right? All the data that is persisted is going to be stored in the secondary storage. By secondary storage, I mean your hard disk drive. Okay, so your laptop, whatever your files you're downloading, whatever data that you're downloading, whatever movies you're downloading, are going to be present in the secondary storage. Is that clear to everybody? This is the place where the actual retention of data really happens. But now, when you want to work and do some computations by your processor, so let's say this is the processor or the CPU of your computer, and now your CPU wants to run some logic. It might want to run some code. It might want to do some calculation. It might want to read the file and figure out what are the contents of the file. It might want to change the contents of the file. It might want to perform an addition, a subtraction. Whatever your CPU is going to perform, CPU needs access to a memory that is going to be very fast and that is going to be closer to the CPU. So secondary storage is not what the CPU directly interacts with. The way computing works is that whatever your processor needs to work with, or whatever data your processor needs to work with, is actually stored in primary memory. Primary memory for now, actually the reality is primary memory consists of registers, different levels of registers, and then RAM. But to simplify, let's assume for now primary memory means RAM. So now whatever data is needed by the processor to do its computation, to run its business logic, will need to be present in the RAM. Okay, the RAM is essentially not persistent storage. I hope all of you understand this. RAM is temporary storage, which means that the moment the machine restarts, the data is going to be deleted. The best word is volatile. So RAM is volatile. So you are not going to have anything persisted here. It is just going to be temporarily available. So let's say I want to do some computation, and that computation needs to happen on some underlying data. So you are going to fetch portion of the underlying data to the RAM. And don't get confused by the diagram that I've drawn. Based on the diagram, it looks as if the storage and the RAM is of equal size. The reality is that the RAM is going to be much smaller than the storage. The storage, let's say, can be of order of gigabytes and terabytes today, but the RAM will be of a lot smaller order. So RAM is going to be smaller anyhow. So small data that you copy from the secondary storage, you bring it to the RAM, and now your CPU is going to work with the data present in the RAM to get the computation done. Now, if you only have the entire load of the service running on a single machine, the CPUs are going to be doing a lot of computations. How many of you understand that? So let's say Sridhar is a user to my Delicious service. He wants to come and he wants to see his details, the bookmarks that he has created, or you want to create a new bookmark. And let's say I have 10 other users who are right now parallelly working with the service to either create new bookmarks or view their bookmarks. Now understand, for each of their requests, I will have to run some code on the backend to process their request. How many of you appreciate that? For every request that is coming to my server will have to run some code. That code is going to run on the CPU. So whatever code the CPU is running, for each of these iterations, I will need some data in my RAM. And given the scale will become big, the amount of data that needs to be present in the RAM will also become big. But the present size of the RAM will start to become a bottleneck. Achut, does that make sense? Achut, does that make sense? Okay. Okay, so I hope that makes sense. That's the reason why RAM will become bottleneck. Similarly, if you talk about the memory card, if you talk about the network card, so what does the network card mean? Then let's say this is a machine, right? It might be connected to a network, or let's say to a optical fiber cable, or to a Wi-Fi connectivity that can handle a particular bit rate. For example, let's say my Wi-Fi or my network can let's say support 16 Mbps. Let's say I'm just taking a crude example. Let's say my network can support this much. This is my network bandwidth. But every machine has a network card. That network card essentially says that I am going to allow whatever data is coming from the outside world to go inside the machine. I will basically allow the machine to read the data coming from the network. Now, this network card in itself is going to have some bandwidth or some bit rate. So if the bit rate at which the network card can read is much smaller than the network bandwidth, then how many of you understand, no matter how good your network bandwidth is, given the rate limiting step will become the network card bit rate, and hence it is actually going to make your entire setup slow. So your network card's bit rate can start becoming the rate determining step. If you remember chemistry, and if you remember the different reactions that happen in chemistry, you would remember learning about the rate determining step, the step that is slowest in the chain reaction, which determines the rate at which the entire thing can happen. Same idea here, that if the network card has a slower bit rate, then no matter how fast the network is, the network card will play the bottleneck role, and hence your number of operations that can happen per second are going to be compromised. Is that clear to Achyut, and is that clear to everybody in the class? Okay, cool. Okay, they could have used the browser local storage. Ajinkya has a Rahul. Basically, bitrate of the network card is a sticker information. So basically, your network card comes with a predetermined bitrate, and you can actually go to the settings of your computer also and figure out the bitrate of the network card. But actually, when you buy one, it actually comes as a sticker information. Anyhow, now let's know network card will not have a different IP address of its own. Okay, so guys, I saw similar ideas of questions in the last class as well, and I'm seeing similar ideas today as well. So I will take a detour once again and answer one very small idea. Basically, explain one very small idea, and then I will move on. But I want to reiterate one thing for the benefit of everybody in the class. Guys, do not use the chat box as small issues that come to your mind. Don't use the chat bot to take the class to different directions for small things that come to your mind. If something is big, feel free to raise your hand, feel free to put it on the chat bot. I would be more than happy to take it. But if something is small and you can actually wait for the right time for that question to be answered, please be respectful for everybody's time and put on the questions tab. You might have noticed we have just spent 1.5 class together, but understand that I am a person who never wants to let any question go unanswered. So if I will see a question, my soul will just want to somehow help you answer that question, right? But that essentially means if I keep on doing that, that is unfair to everybody else in the class, right? So I'm not someone who wants to read a question and ignore it. So please be mindful for everybody's time and put the question in the questions tab if it can be. If it's a burning question, if it's a question that you can't wait without getting an answer to it, put it on the chat, raise your hand. I would love to unmute myself and yourself. Obviously, I would love to unmute yourself and I will engage with you and answer that question for you. Okay, so let's do that. But given I read something and I want to ensure that everybody in my class understands that, so guys, I will take a quick detour and explain to you that there are two kinds of things in the internet world. One is the IP address. The other is the MAC address. Okay. Now, my dear friends, the MAC address is a property of the device, and IP address is basically property of network. So I have a mobile phone. My mobile phone is a device, and it has a particular MAC address that is burnt into the device. So my device has a MAC address. But now, if I connect this phone on this network of my home network, it will have a different IP address. If I go and connect this to some other place, it will have a different IP address. So IP addresses are properties of the network. So I have a laptop. I connect that laptop to this lease line that I've gotten. it will start working on this IP address. Tomorrow I take this laptop and connect to some other place, some other network, it will start listening on that different IP address. But the MAC address will remain the same. Similarly, when you look at the network card is a device. It will have a particular MAC address. Then the network card is listening on a particular IP by the virtue that you have connected that network card on that IP. Does that make sense? So the closest analogy that you can always remember, I am a human. I am a person. My name is Tarun Malhotra. So Tarun Malhotra happens to be an address, my MAC address. Tarun Malhotra defines who this person is. But am I living in this house? Then my IP address can be the address of this house. Tomorrow I shift to a different house. My IP address or the place where I can receive data is going to be a different address. So your house address can be thought of as the IP address, and you yourself, your name, your identity can be defined as your MAC address. So all the devices are by default going to have a MAC address of their own, and all the devices, when they plug into a particular network, they can get an IP address by the virtue of being connected to that network. Does that make sense to everybody in the class? Does that make sense to everybody in the class? That's great. Now I will ensure that we are not going to now all of us should together ensure that we are not going to digress a lot. Put only burning questions in the chat. Otherwise, use the questions tab. I hope that is agreeable to all of us, right? That's a rule of the society that we're going to build in our classes. Okay, great, cool. So now we discussed that here there are a bunch of bottlenecks, and now let's talk about what are the ways in which we can scale. So how to scale? This is the question. And my dear friends, how to scale? The answer to this question is that there are two approaches to scaling. Approach one, my dear friends, is called vertical scaling, and approach two, my dear friends, is called horizontal scaling. So whenever you see a scaling challenge, you can scale your system in two different approaches. One is called as vertical scaling, the other is called as horizontal scaling. Let's try and understand both of them. When I talk about vertical scaling, I mean that I am wanting to replace my current machine. So know that let's say my current machine is giving some bottleneck, is having bottlenecks. If my current machine is having bottlenecks, then I want to replace my current machine with a more powerful, a more fancier machine. Okay. On the other hand, when we talk about the other thing, Rohit, I apologize for that thing. I will work with the team to ensure that doesn't happen in the future. So I'm sorry if that happened in the last class. Okay, cool. So now let's come to the other approach. The other approach is horizontal scaling. Horizontal scaling basically means, my dear friends, that we are not going to introduce a new beefier machine, or I'm not going to introduce a new fancier machine. I'm not going to include a new heavier machine. Rather, I am going to introduce an army of small machines. So rather than saying that I'm going to invest in buying a new beefier, bulkier, more powerful machine, I will keep on using small machines that have very little power in themselves, but I will rather use an army of them, a collection of them, a group of them, so that all these machines can pool their resources, and get the job done. So let me make you appreciate this with the help of an example. I want everybody in the class to pay complete attention. Vertical scaling is a simple idea. That, hey, let's say this is your network, and you were listening on your IP address, and right now you had this machine. This machine had some configurations, right? So for example, this machine had, let's say, 5 GB of hard disk. We're talking about the older system. Of course, in the world of today, you have much bigger. So let's not talk about older one. For this example, let's talk about today's systems. For example, let's say you might have a machine which has 1 TB of hard disk. You might have a machine that has, let's say, I will answer that. Let's say we have a machine which has, let's say, 5 GB of RAM, and let's say we have a machine which has some particular network card, etc. Vertical scaling will mean that if this is becoming a bottleneck, I will replace this machine and say, okay, my network, of course, will remain the same. If I was listening at IPA, I will still keep on listening at IPA, so nothing on the network changes. But I'm going to replace this with a bulkier machine where, let's say, now my hard disk can become, let's say, 5 TB big, and let's say my RAM can become, let's say, 1 TB big. So whatever is your bottleneck, you introduce a new machine where that particular bottleneck is fixed. How many of you understand what vertical scaling is? That please replace the main machine, buy a new one, and plug that new machine in where you have a lot more power, where you have a lot more resources. Whatever resources were getting bottleneck earlier, please buy a new machine where those resources are much higher, so that you can scale. Which means if the previous machine was able to handle 1,000 users, the new machine, because it has a much higher scale, much higher configurations, can, let's say, handle 10,000 users. So my dear friend, assume the processing power is limited. I just took an example that, let's say, in the previous machine, these two were the bottlenecks, and let's say that the CPU was not the bottleneck. So you replace with a new machine where these two elements are much bigger. If in your example the CPU was the original bottleneck, then you would replace with a machine where the CPU is a lot bigger. Is that making sense, everyone? Kiran, we will come to that. That's true. We'll come to that. Sai Prasad, that's what we're trying to do. We're trying to replace with a bulkier, beefier machine that has more configurations. Okay, so vertical scaling makes sense to all of us. Is that correct? Now, my dear friends, before I move on, I want to touch one very important aspect of system design. Everything that I'm going to teach you in system design, my dear friends, is going to be trade-off oriented. There is not going to be a single decision in my entire curriculum where you can say that, hey, out of these two decisions, decision one is always the better decision to be taken as compared to decision two. That's not how system design is. In system design, whenever and every single time, whenever you are presented with multiple opportunities, and system design is full of that. I, in fact, say that system design is a bed of trade-offs. So you are going to see multiple opportunities in the curriculum when you are going to see that there are 2-3 approaches. Every approach that you take is going to have some advantages and some disadvantages, and every other alternative is going to have some other advantages and some other disadvantages. You, as a good systems architect, need to know the advantages and disadvantages of all the approaches that you're going to learn in the curriculum. And now, given a real life problem, we are going to now evaluate, use our brain, and figure out for that real life problem what is more important for us, which trade-off is more important to us, and ultimately using that information, we are going to decide whether we want to go with approach A or approach B. Am I making sense to all of you? So never ever fall into the misassumption that when I am giving an approach, it only looks bad or it only looks good. Every approach is going to have two sides of the coin. There are going to be advantages and disadvantages, pros and cons, and strengths and weaknesses. We need to understand both of the sides of the story very well, and then given a problem, we need to apply what makes more sense. Right now, vertical scaling, I've just explained that you replace the machine with a bigger machine, so that whatever was the bottleneck resource early on, now that resource becomes a lot more healthier, a lot more beefier, a lot more advanced, so that you don't face the same scaling challenges that you were facing earlier. This is what in one line is vertical scaling. I will come back to advantages, disadvantages a bit later, but let me first explain logically what horizontal scaling also is, right? So even though I've given the definition, but let's try to draw a diagram to understand what horizontal scaling means. So let's say originally I had one machine which was running with some credentials, with some configurations, right? So let's say this machine has some small, let's say it has a 2 TB hard disk, or let's say a 1 TB hard disk. So let's say it has a 1 TB, or let's say even less than that. Let's say it has a 500 GB hard disk, and let's say it has a 1 GB RAM. So it is a lot less powerful a machine. Now, of course, this is facing scaling challenges. Rather than throwing this machine away and introducing new, bigger, bulkier, beefier machine, I'm going to say that, okay, now rather than getting the job with one single machine, I am going to add a lot of small, less powerful machines. And all of these machines will exist like a cluster of machines. So I will have now, rather than replacing the machine and buying a bigger machine, I can have cluster of small machines or simple machines. And now whatever job needs to done, whatever code you need to run, whatever story you need to do, all the processing, all the storage, all the compute is now going to spread out between these machines, and these machines are going to work in unison to get the job done. Okay, so let's say if earlier your storage was becoming a bottleneck, your processing was becoming a bottleneck. Now rather than having one single machine, you have a cluster of small machines, so that all of them can now work together. And let's say the storage can get divided. Some things can get stored in machine 1, some things can get stored in machine 2, some things can get stored in machine 3. The compute gets divided. Some requests might be handled by machine 1, some requests might be handled by machine 2, some requests might be handled by machine 3, and so on and so forth. Is that making sense, everyone? Is that making sense, everyone? Now put your question in the questions tab, or wait for me to go on. Probably your question will automatically get answered. Okay, cool. So this basically horizontal scaling. Let me write it down. Horizontal scaling means that we employ a group or a cluster of machines where each individual machine may be small, but they together pool their resources. So all of these machines are going to pool their resources and act as one single system. So you're going to act as if you have a single system in front of you, but the reality is that these small machines are pooling the resources and getting the job done for you. Now, a lot of questions, a lot of things that are still not clear here, because hey, how can machines pool their resources? How can they work together? We are going to see that as we move along in the class, as to in the curriculum, as to what all do we mean by dividing the things in a horizontal manner. What do we mean by horizontal scaling? Okay, guys, it's 15 minutes in the class, and I'm getting a comment from someone that hey, I'm teaching very fast today. Now, guys, the reason why I sort of increased the pace a bit today is based on the feedback that I got in the last class, where some of you wanted me to go a bit faster, and where some of you were worried that hey, we should not take the class beyond 2 hours, 30 minutes, or something like that. So now, now I just got one comment where somebody saying that hey, I'm teaching a bit too fast. And if you remember in the first class, I told you that we are going to use the first few classes to figure out what speed works for the most of you. So I think it is only fair if I start a poll in the class right now, where you guys can help me decide how we are going, and we are going to modify our class based on what the majority of the class wants. Okay, Bharat will come to that. Let me create a very quick poll so that we are not wasting any class, and we are not wasting or not sort of taking it in a manner which is not comfortable for most of you. So you will see a poll in front of you in a minute. Let me create the poll. How do you see the current pace of teaching in our class? So you can either say, let's say that hey, we are going good. I am able. Just give me a minute. I'm just creating the poll, and I will share that poll to you. Just give me a minute. I'm able to understand the discussion. Or you can say that hey, we are going too slow. I feel like sleeping. Or you can say that hey, we are going too fast. Okay. So guys, you have the poll in front of you now. I want all of you to answer the poll so that we can then decide accordingly. Either you can say that hey, the speed is going all good, you're able to understand what is being discussed, or you can say that hey, we are too slow, and you feel that hey, Tarun, this is so boring, I might sleep. And for those who feel this is too boring, they just have to wait for 2-3 more classes and let the course become a bit difficult. Then probably you will not feel it is too boring. So for those of you who are feeling it's boring, they will have to essentially change their outlook in a few classes. I can guarantee that. Okay, but anyhow, let's see how many of you find this too fast, too slow, or you find the present pace comfortable. And once I get this poll, of course there are going to be people in all the 3 buckets. But as you understand, in a classroom environment, the instructor should do what suits the majority of the class. So we are going to do what suits the middle section of the class, and some people will have to bear with too slow in their opinion, and some people have to bear with too fast in their opinion. Okay, yeah, Jitendra, we will try to get that also sorted over the next few classes. That's my strong opinion that we should go to 11:45, but we'll see how it pans out. Okay. So 7 seconds are left. I want everybody in the class to answer, participate in the Festival of Democracy, and let us know what do you feel. Okay, so this poll result looks like I have bugged it because it looks like a beautiful bell curve. Do all of you see that? It looks like a beautiful bell curve, right? It looks like that hey, 72% of people, which is the big chunk of the class, feels that we are going all fine. So 15% of you say that hey, we are too slow and we feel like sleeping. For those 15% of you guys, one personal comment for you guys: if you feel like sleeping, as I said, wait for 2-3 more classes. All of your sleepiness will vanish, and you will say that oh, Tarun, I need to drink some coffee, but I can't afford to sleep in your classes. So give me a few more classes because things are going to get real and they're going to get tough and interesting as we move on. 30% of you say we are going too fast. I totally appreciate your concern, my dear friends. But my suggestion or my request to you would be that please try to catch and please try to bear with me in the class, and then spend some time in revising, my dear friends, so that whatever you are not able to catch in the class, you are able to make up for it by revising. Okay, so does that sound like a good plan, folks? I have suggestions for all the 3 buckets. The people who are enjoying, let's enjoy together. The people who find it too slow, wait for a few classes. The people who find it too fast, please try to tag along, ask questions, whatever questions come to your mind, but then spend time in revising so that you can compete with the guys who are saying the class is too fast, too slow. Okay, guys, cool. Let's come back. Thank you for the poll. Okay, so we are talking about horizontal scaling is that you introduce a bunch of machines together who will get the job done together. Now, a lot of you have these ideas ideas like replicas or sharding, etc. I have not formally introduced these concepts right now. If you remember in the first class, I would have mentioned that in my batch, I need to do a lot of heavy lifting to unclog the previously set up ideas in the brain. So we need to do a lot of unlearning as well. So Sagar, just wait for some time. Don't worry about replicas right now. Replica is a different concept. Sharding is a different concept. I'm going to formally introduce both of these concepts later. For now, just imagine that there are multiple machines who are somehow together doing the job done, getting the job done for you. To give you some more insight, let's say, if I want to make it slightly more clear, I want everybody in the class to pay attention. Let's say each of these machines had a storage capability of 500 GB. Okay, let's say 500 GB of storage can be done by machine 1, 500 GB can be stored by machine 2. And let's say I wanted to build a system where overall I wanted to store 4 TB of data. Now, if each of the machines can only store 500 GB, can you understand that can I probably get 10, 15 machines together who can together combined manner hold, if I let's say have 20 machines, they can in a combined manner hold, let's say 10 TB of data, but I can use those 20 machines together to very comfortably store 4 TB of my business data. How many of you understand that? That I can pool my machines, where the machines can pool their resources together and together get the job done. Is that clear to everybody in the class? Is that example clear? Let's say every machine will only afford to support 500 GB, but I can introduce 10 machines or 20 machines which can together support 1 TB of, let's say 10 TB of data, and now I can very comfortably store 4 TB of data in them together. So basically, I am letting my machines pool their resources and get the job done. Let me give one more example, and then I will unmute Nawab. Probably Nawab has a burning question because that's why he has raised his hand. But let's actually let me give you one more example. Before I give you one more example, Sai Prasad is trying to correct me in my mathematics. He's saying, Tarun, you mentioned that you are going to use 20 machines where every machine is 500 GB per machine. So that actually, if my calculation serves me right, that becomes 10 TB of data, but you only wanted to store 4 TB. So I would want to correct you that you don't need 20 machines, but you only need 8 machines. Sai Prasad, I also can do this calculation. But the reason why I purposefully took a bigger number, my dear friend, is going to become evidently clear to you in the following classes. But to just break the suspense a bit for you, whenever you are building systems that can scale, you would always want to have your storage at any given point in time not using more than 50-60% of the available storage. How many of you appreciate that? You would not want to be running a system where 100% of your storage space is occupied. You would want to have a good buffer of free space so that as your storage space is continuing to grow, you can use that buffer and easily expand. Okay, so you would never want to run cut to cut. That if I only need 8 machines, every machine I will fill to the brim. If you start filling every machine to the brim, the machine's probability of failure will increase many folds. The probability of you not having enough space to incorporate new data is going to be very, very high. So that's why we always take slightly higher, or let's say significantly higher estimates than what we actually require. And my dear friends, we are going to formally discuss all this details as to what should be the percentage of data that you should be using, etc. in the following classes. But I just gave you a small sneak peek into it. Does that sound good, everyone? So I just give you a quick sneak peek. We're going to formally discuss this in the following class. Okay, anyhow. How will all of these machines act as a single machine? How many of you have this doubt in your mind? How many of you agree with Vinod that this looks fancy, but how can multiple machines somehow magically pull together and work as one? A lot of you have that doubt. I totally buy that doubt for now, but wait for some time and wait for some classes. This will become more and more clear. For now, hear me take me on my face value and assume that somehow these machines will work together and get the job done. Okay, now guys, one more let me set the expectations correct in one more manner. Okay, now some of you might be thinking that Tarun acts like a baba all the time. He keeps on giving us gyan, but think about it. We are starting a long module which is going to span multiple months. Don't you think we deserve some time to come together and appreciate the common language that we're going to use in the course? Don't you think we deserve some time? So we deserve some time to understand each other and to make each other comfortable that what are we going to do further. So for those of you who think that, hey Tarun, you are probably not explaining all the doubts just now, try to understand, my dear friends, high-level design is a very complicated science where you can design systems at scale. I am somehow trying to chip at that big ball of information and pick up small bits of pieces, present it to you, explain it to you. But as we know about more and more pieces, the story will start tying up a lot better. Does that make sense? So right now it might not be clear to you how can 10 machines together pool together and act as one unit, but the story will tie up correctly in the next few classes when we reach that point. For now, just assume that every machine has some resources, they can pool their resources together and we can get the job done. Does that make sense? Cool. Thank you. Now, one more example that I want to give before I move on, right? The second example I want to give, let's say one machine can handle 10 users at any given point in time. So I have one machine, 10 distinct users can connect to me at any given point in time. But my scale has increased so much that I really need 200 different users to connect to me at the same time. So if one machine can only support 10 users, then potentially I can introduce 20 machines in one cluster where 10 of the users can come and connect here, 10 of different users can come and connect here, and so on and so forth, so that I can scale the overall number of users that I can handle in the entire cluster. Am I making sense? Am I making sense to everyone? Nawab, pods in Kubernetes is one way to represent this, but what we are learning is a very, very foundational concept, my dear friend Nawab, and pods in Kubernetes is one way to implement it. Okay, cool. So now you appreciate that just like we could have divided the storage across our member machines, we can divide the load also across our member machines. So let me summarize what I just explained to you. In horizontal scaling, we pool resources of multiple machines together, and then the compute, basically the second example is the example of compute. The first example was the example of storage. The compute and storage can get divided between these member machines, and the entire setup can act as a unified cluster. So the entire setup can act as a unified cluster because inside that cluster you have small machines that are together doing the job for you. Now, my dear friends, this horizontal scaling, let me break one more thing for you. This horizontal scaling, my dear friends, is going to be the bedrock of distributed computing. How many of you have heard this term, distributed computing? How many of you have heard this term, distributed computing? So, okay, some of you have heard it, some of you have not heard it. My dear friends, the world of today that we see planet scale systems possible. You see Google has stored the knowledge of the entire world in its machines, right? If you want to search any website, Google has that website indexed. Think about Facebook. Facebook has 3-4 billion users, and Facebook knows a lot about those 4 billion users. Facebook know about who is the friend of whom. Facebook know which user stays where, etc., etc. So imagine for a planet scale, we now have a system which has a social media. For a planet scale, we have a retrieval system for planet scale. We have so many systems in the world today which are planet scale. Now think about it, my dear friends. Is it really possible for all of this magic to be architected or to be orchestrated by singular machines or by individual machines? The answer is a big no. All of these systems, my dear friends, to the core of it, are built in a distributed computing manner or in a distributed systems manner. That hey, for Facebook to run, Facebook potentially will have 1 lakh different machines or 2 lakh different machines that are going to somehow work together, where some of them might be acting as databases storing the data, some of them might be acting as some other database storing some other kind of data, some of them might be acting as machines that are going to run the code, some of them might be acting as some machines that are going to do some security checks, some of them may be acting like some machines that are going to send notifications. But in the sense, these systems are going to employ lakhs and lakhs of machines that are somehow together going to work with each other and make that platform run. Am I making sense? So this distributed computing basically means that you are going to have so many machines employed together, where the computation load is going to get divided between them, the storage load is going to get divided between them, and they are going to together work as one backend and get the job done. A cluster is one unit of the backend, and I'm going to explain this line in the following classes, that the cluster of machines that we're talking about is one organ of the entire human body. So let me give you an analogy once again. All of us have studied some basic biology. Is that right? All of us have studied some basic biology, right? So we have a body. All of us have a able body that God has given us. In that body, my dear friends, you will see different organs, right? You have a heart, you have a brain, you have lungs, etc., etc. Each of these can be thought of as a cluster of cells. So let's say your heart is a cluster of heart cells. So each of the independent cell has some very small power, but together when the heart cells combine and they form a heart, which is like a cluster of heart cells, or let's say an organ, it does some beautiful job. Am I making sense? And now for the entire body to run, you have different organs. So just like that, in any real life system which is at good scale, you are going to have a lot of different organs of the system. Every organ can be thought of as a cluster. Inside that organ, you will have a lot of cells that independently might not have a lot of value, but they will pool together, and they will form that organ for you. Am I making sense? So let me draw that analogy right here so that you never forget it. In your life, you'll never forget it now. So I will say human body is analogous to the entire system. So let's say I am talking about a Facebook, I am talking about a Google, so I'm talking about an actual system. So that is akin to a human body. A particular organ in the human body can be thought of as one particular cluster. Cells of a particular organ, so let's say cells in an organ, can be thought of as machines of that cluster. So guys, will you always remember this, my dear friends? Will you always remember this? This is a good analogy that you always remember, and you will never get confused. Okay, and this is going to become more clear in the computer science domain in the following classes. But for now, let me take you back to a problem that we have not yet addressed. Let me first see how many of you understand the problem. Okay, so the diagram that I've been drawing from the last class looks something like this. That I have a laptop, which is, let's say, owned by the founder of Delicious. This guy got a public IP address, and this laptop was running. This laptop was running on this IP address. Then this guy owned a domain name and got it registered on the DNS. And now any client in the whole world can enter the domain name, go to the DNS, and ultimately come and connect to this laptop at this IP address. Is this clear, everyone? Is this clear, everyone, my dear friends? Is this clear, everybody, my dear friends? This is clear. Now I ran into a bottleneck. So this is the beautiful picture. I ran into a bottleneck. Because I ran into a bottleneck, what did I do? I changed the system a bit, and I said that my laptop, let's say one option that I had was vertical scaling. In vertical scaling, the story is very simple. That you throw the laptop in the dustbin, or let's say that guy used to live on the 5th floor of the building. He picked up his laptop and threw it out of the building, forgot about it, and changed that laptop with a much more bulkier machine, which has a lot more beautiful specs. That new machine again was started listening on the same IP address that he had bought or leased, and now any client in the whole world, when they enter the domain name, because of the DNS, they will be able to come to and talk to this new machine. Is the vertical scaling picture crystal clear to all of you? That the only thing that really changed, that you threw the previous laptop and you changed it with a new bigger machine. But now, when I said that for horizontal scaling, you don't go and buy a Superman computer or a supercomputer, but rather you say that I am rather going to buy more smaller laptops from the market, or I will pull them from my friends, and now I will have a bunch of laptops or a cluster of small machines. But remember, I still have one IP address that I had bought I just bought one IP address. I just had a DNS mapping where Delicious was mapped to that IP address. Now, given I no longer have a single machine on my backend, but I have multiple machines on the backend, so how will I decide which of these machines will here on that particular IP address, or which of these machines will work on that IP address? Is that a genuine question? Is that a genuine break? Is that a genuine missing piece in the system that we are designing? Guys, are you with me? How many of you appreciate that there is a missing piece, Tarun? That why are you hiding that from us, Tarun? We don't like you. Why are you hiding that information from us? Guys, do you understand that there is a bit of information that is missing to complete the story on horizontal scaling? Can everybody in the class confirm that we understand that there is a missing story? The missing story is that I only bought one IP address, and now you are saying I'm going to have 20, 30, 40 different computers in the cluster. Which of these machines will hear on that IP address, and how will they communicate with that user? Now, one approach, if the question is clear to all of you, one approach that some of us might think, because we are normal engineers and we are trying to think of the possibilities, one approach that might come to our minds is, can we buy more public IP addresses and register all of them in my DNS? Do you think that would be a good idea? If today I have 20 machines, should I go and buy 20 different IP addresses? Tomorrow, if I have 30 machines, should I go and buy 10 more IP addresses? And every time I buy new IP addresses, should I go and add them to my DNS? The answer is no. You should not do that. Do you remember that, guys? Do you understand that? You should not do that, because that's not the right way. You're not going to buy a new DNS line for every new machine that you're employing on the backend, right? So the reality is that we piggyback on the idea of private networks. I'm not sure how many of you remember that from my first class, but even if you don't remember, if you remember it, then you remember that there was an edge machine. There was an edge machine in the private network that can talk to the outside world. Just like that, we can have a special kind of a machine which we are going to call as the gateway machine. So guys, do you know there's a Gateway of India in Mumbai? Do you know why was that Gateway of India created? The Gateway of India was created because when the Queen of England was visiting India, we or the British government wanted to create a gateway through which the Queen will enter India. Now, how many of you understand that based on the same idea, you are going to introduce a gateway machine so that any client, whenever they are going to make any request, the request is going to ultimately get connected to the gateway, because that gateway machine is going to be the machine that is going to be hearing on that IP address. How many of you understand this? This is going to be the entry point. Nawab, I appreciate your questions, but if you can have a bit of patience, you will see that I will be answering your questions automatically in the flow of the class. What you're saying is absolutely right, but just have some patience. See that I will automatically answer that question in the flow of my class. Okay, cool. So guys, I want everybody in the class to appreciate this, that let's have a dedicated machine whose only job is to act like a postman, or whose only job is like to act as a guard, a gateway. Okay, anybody in the outside world want to connect to my system? Please come and talk to me, because I have the IP address, the public IP address where I am sitting. How many of you appreciate that? The gateway is the machine which has the public IP address. Anybody in the outside world will come and connect to the gateway. And now the gateway's job is to forward the request to one of the internal machines. So the gateway's job, So first of all, the gateway's job is to be the first point of contact for the outside world. Is that clear to everybody in the class? A special machine who listens on that particular public IP that you bought, and whose only job is to be the guard or to be the first point of contact for the outside world. Point clear. Now, tell me the second thing. That's right, Nawab. Tell me the second thing. If the only machine that is going to talk to the outside world directly is the gateway, do you think the other machines in my network, in my backend, will need public IP addresses? Do you think I need to give public IP addresses to the other guys? Beautiful. I can see in front of my eyes that you guys are understanding the concepts. There is no reason why I should spend money and make the internal machines available on the network. Am I making sense? The internal machine should not be directly reachable from the outside world, because those are internal to me. I don't want people to talk to them directly. I want people to come to the gateway. The gateway will somehow forward the request to the backend guys. So these internal machines, I want to see you guys smile. Please tell me after understanding this, do you smile or not? These internal machines will only have private IPs. Please confirm, guys, if this makes you smile, because you understood something beautiful. That the internal machines need not have public IPs. The only machine that needs to have a public IP is this guy, which is the gateway. Okay, that's great. Now, I see a lot of questions. Things like, thank you for smiling, Gautam. Thank you for smiling, Devendra. I'm also smiling, so I hope all of us are smiling. But at the same time, I hope that our family members are not looking at us and thinking that, hey, what's going on? Are these guys gone mad? Why are they smiling for no reason? Okay, but still we should smile, right? That's good for our health. Anyhow, let's come back. Enough of poor jokes. Now let's come back. What I'm trying to tell you is the gateway is the first point of contact for anybody outside from the outside world, and I can actually draw a dotted line here, and I can tell you that this dotted line forms my backend. How many of you appreciate this? This dotted line, my dear friends, forms the backend, and the gateway is the first point of contact, and gateway is the only machine that is running on the public IP. Everybody else inside can only have private IPs. Now, if you understand this, just like we learned in the intranet in the first class, that you can have an intranet where every machine has private IPs, only one edge machine is going to be there, which is going to have both the public and the private IP. So my gateway is going to have both the public and the private IP. Is that clear to all of you? The gateway is going to have both public and private, and the inside machines are only going to have private. Now, Shiva is asking a beautiful question that I must answer. Shiva is saying that this entire thing, is this a system? Or is this a cluster? Which means, is this entire thing a human body, or this entire thing an organ? So Shiva, let me answer that for you. The dotted line that I've drawn, is the entire system or your entire human body. Right now in my human body, I have drawn only one cluster, and this is a cluster, or this is basically an organ. Going forward, I am going to draw a lot more organs in the human body, and this dotted line is going to become bigger and bigger. How many of you appreciate what I'm saying? Right now, because I'm just introducing the concepts to you, I just drew a dotted line. That dotted line is the entire backend system. In that dotted line, I've just drawn one layer of machines, basically only one cluster of machines, which means one organ of the human body. Going forward, I'm going to add more and more organs of the human body. Does that make sense, guys? I'm going to add more and more layers. I'm going to add more and more clusters in the system going forward. Now, my dear friends, a lot of questions that are popping in our head, right? And they're not letting us sleep. Things like, nobody should sleep, by the way. Things like that this gateway is the single point of failure. Things like, how will this gateway forward the request? What algorithms will this gateway use to forward the request? That is what I'm going to cover in the remaining part of today's class. So don't bother, don't worry. Whatever questions are coming to your mind, those are the questions that I'm going to cover in the remainder of the class. So it's 10:22. Let's study for another 10 odd minutes, and then we'll take a 5-minute break. Sounds like a plan, folks? Let's study for another 10 odd minutes. Then you can take a 5 minutes break to recollect yourself, and then we can continue the class. Okay, great. So everything makes sense at this point in time. If you want, I can take a pause and write this for you so that you don't forget what I'm talking about. The horizontally scaled system. The horizontally scaled system will need to have a gateway machine. I hope everybody in the class appreciates this, that the horizontally scaled system will need to have a gateway machine. Point 2, my dear friends, this gateway machine will be the first point of contact for the outside world. That is also clear to all of us. Third point, this gateway machine will forward outside requests or requests coming from the outside to internal machines. Am I making sense to all of you with the third point as well? That this gateway is going to act as a forwarder and is going to forward the request to everybody else in the backend system. Now, the fourth point that I can write is this gateway, because it is going to talk to the outside world as well, and it is going to talk to the inside world as well. This gateway, my dear friend, should have both the public IP and the private IP. Is that clear to everybody in the class? Is that clear to everybody in the class? Can all of you confirm this here? And then the last point, all other internal machines can just have private IPs. Are all of these points crystal clear to every single person in my class? Okay, why gateway needs a private IP? Thank you for asking that, Chinnari. Chinnari, think about it this way. When I talked about the intranet, there was an edge machine. The edge machine will need a public IP to talk to people outside the internet, basically on the internet, whatever machine wants to talk to us, the edge machine needs to have a public IP. But the edge machine also needs to talk to the internal guys. And to talk to the internal guys, it needs a private IP. because the internal guys only have a private IP. They can only talk to each other only when the other guy has a private IP. They only understand the internet space. So if the edge machine does not have a private IP, the edge machine will not be able to talk to internal machines. Generally, does that make sense? So because the edge machine needs to talk to inside world as well and outside world as well. So to talk to the outside world, it needs a public IP. To talk to the inside world, it needs a private IP. I hope this makes crystal sense to all of us in the class. Now, my dear friends, before I go on and talk about load balancers and how will the load get distributed, etc., etc., I think we need to do justice and talk about vertical scaling versus horizontal scaling. That is not part of the curriculum, but I always have covered that in my batches. So I will go and talk about that, my dear friends, that what are the advantages and disadvantages of these two kinds of scaling before I go and talk about load balancers. So I want everybody in the class to pay attention. When I say I'm doing vertical scaling, because I am doing vertical scaling, that is, I'm going to buy a new machine and I am going to introduce a new bigger machine, I can argue that vertical scaling has one big advantage. Please cover when to choose what. Sorry. Okay, yeah, that's what I'm saying, right? Vertical scaling, my dear friends, has the biggest advantage that it has a very simple architecture. How many of you understand that? That your IP, public IP, is just connected to the direct machine, and anybody from the outside world that comes and talks to your backend, they just need to talk to the vertically scaled machine, and there is no complexity. There is very simplicity of the architecture. But then this is a pro, so I will say this is an advantage, but there are a lot of disadvantages as well. So let's talk about the disadvantages now. Okay. So what are the cons? And don't be quick. Don't be quick to jump on the conclusion that you hate vertical scaling. Remember, everything in system design is a trade-off based algorithm, right? Everything is trade-off. So don't jump to the conclusion that you hate vertical scaling. But let's hear the trade-offs, the cons. The cons are, my dear friends, the first con of vertical scaling is that hey, you still have a single point of failure. So you have introduced a new machine, spent a lot of money, bought a fancy machine, but hey, you still have only one machine, and if that machine fails, everything goes down. How many of you understand that? The single point of failure problem has not been solved. Can everybody agree with that? Point two. More and more fancier machines that you buy, they are going to become more and more costly. So vertical scaling, my dear friends, is going to be costly. Now, I'm not sure how many of you understand that, but buying one iPhone is costlier than probably buying 5 Oppo phones. How many of you understand that? Buying one iPhone is costlier than buying 10 cheaper phones, right? Because when you want one machine, now this is a very simple and simplistic example that I'm taking, but the idea is that when you want to buy one machine that has more and more power, when the same machine has more and more power, the rules of physics say that beyond a point, heat dissipation becomes very difficult, and that is why you have to invest in a lot better quality hardware so you can pack a lot of things together. And hence, by the laws of physics, a more vertically scaled machine is going to be costlier than using 10 or 100 smaller machines. How many of you understand that? How many of you understand that? That it's going to be costly to have a vertically scaled machine. Point three, how many of you have heard the Hindi kahavat, ki hati bandh ke rakhi hai? Now, some of you don't understand Hindi, so let me try to loosely translate that to English. So it means that, hey, I have bought an elephant. It looks good to look at the elephant, but now I have to feed him all the time, okay? Because the elephant will eat a lot. So hati pal ke rakhna in the Hindi kahavat means that you have invested in buying a resource or buying something that is going to have very high maintenance. You're going to keep on feeding that hati, right? So you're going to keep on feeding that elephant. So the idea is that it is going to have a very high cost of maintenance. You have bought a very, very top level machine. It is going to have a high cost of maintenance. It is going to have high electricity cost or high energy or electricity cost to run it. Now, how many of you understand this? Your electricity cost or your maintenance cost is going to be very high in order to run it. Now, let's talk about the fourth point, which is probably the most interesting thing, right? Let me take a detour. Rather than writing that directly, let me impress upon you guys with the help of an example what I want to say with the fourth point. Now, my dear friends, think about it. Let's say I am building Amazon. Do you think that Amazon is going to have the same amount of traffic every single hour, every single day? Or do you think that when Amazon is running the Big Billion Day sale or the special sales or the Black Friday sales, Amazon is going to have a lot more traffic on those days? How many of you think about the second? How many of you think the second thing is more appropriate? That the amount of traffic is going to be variable. You're not going to require the same amount of traffic handling all the time. How many of you understand that? That your traffic can vary. Right? You do not need the same amount of traffic. You do not need the same amount of capacity all the time. At some points of the day, you need lower capacity. At some points of the day, you need higher capacity. In some seasons, you need more capacity. In some seasons, you need less capacity. Around the sale days, you need more capacity. In the normal days, you need less capacity. Okay, let's strengthen this argument. Let's strengthen this argument, right? Yeah, that's right, Sagar. Absolutely, very good example. Let's strengthen this argument by saying, how many of you remember that there was an app called as Clubhouse? Anybody in the class remember it? There was an app called Clubhouse that was becoming the darling of the VCs during the COVID phenomenon. So it was an app where you can host a voice. What is that called? Sorry, you can have what is that word called? Sorry, I'm getting old and I forget words. But you can host a call or you can host a podcast where people can talk to each other over voice. You will not be able to see their face, but you can hear their voice. So it is like a podcast that you can create and people can join and talk to you. So now that app was becoming the talk of the town. Everybody thought that it's going to be the next Twitter. Everybody thought that it's going to be the next big company. But what really happened? The app crashed, and now all of us don't even remember Clubhouse, which means that there are going to be systems in the world where we are going to see that, hey, probably I'm going to keep on growing my user base. It might seem at some point that the app is so successful that the users are growing every week. Every week I'm doubling my users. But then all of a sudden, one fine day, your user base might come crashing down. These are actually things called as fads. That it might actually be a fad in the market. That hey, you might think you're growing and growing and growing, but then one fine day you might fall and you might sustain at a smaller level. Guys, are you able to appreciate this idea of fads? That your products might turn out to be fads, unfortunately. Now, if you are going to do a fad, is basically a bad fad is something that sort of dies with time. It looks like very promising in the beginning, but then it dies with time. Now, my dear friends, if you are trying to estimate that my user growth is growing and my number of users are improving, how do you sit back and estimate how big a machine should I buy? Because if I have 1,000 users today, and tomorrow I'm expecting it to be 2,000 users, next week I'm expecting it to be 4,000 users, next week I'm expecting it to be 8,000 users, do you think I can estimate like this for the next year and say I'm going to have a billion users after the year? Or do you think that's a very big assumption? That's a very big assumption. It may or may not come out to be true. So when you are investing in buying a machine, a vertically scaled machine for the future, you need to have very good estimation. And if that estimation goes wrong, then you might have bought a machine that was too small or that was too big. How many of you understand that? That it is very difficult to estimate in a growing system that how big a machine should I go and buy next. So let me write down. Very difficult to estimate. So I will write with the green color pen because it's a con. So it's very, very difficult to estimate how big a machine is going to be sufficient. Which means that if you try to do vertical scaling in a product where the scale is increasing rapidly, then you will most likely have bought something that will turn out to be very small in the future. So you have to throw that machine again and buy a new machine, or most likely will turn out that your machine was too big and you are now just wasting resources running it. How many of you understand that a big con in vertical scaling is how do you predict how big a machine do you want? And the last thing is that there is no elasticity, or in other words, you can't support elasticity of scale. Now, what does that mean? That in case your system is such that it keeps on increasing the use case and reducing the user base, or increasing or decreasing the amount of compute that I need. If you buy a big vertical scale machine, it is going to run the same vertical scale machine at all the times of the day. But if you don't buy a big machine, rather you buy small multiple machines, then what you can do during the peak hours, you can have, let's say, 100 machines, and during the non-peak hours, you can shut down 80 of those machines, and you can only run with 20 machines. How many of you understand this? And if you are doing horizontal scaling, it will enable good elasticity of scale. So you look at the elastic, you can stretch it, you can compress it. So in horizontal scaling, there is great elasticity of scale, but in vertical scaling, there is no elasticity of scale. How many of you appreciate that? Because if you buy a big machine, no matter if your user base is growing or reducing, no matter if your app is turning out to be a fad, no matter if your app has periods of less usage and periods of more usage, all the time you will be stuck with running that big machine. So these are the disadvantages of vertical scaling. Each of these disadvantages, my dear friends, are going to become the advantages in the horizontal scaling world. So when I say you have a single point of failure in horizontal scaling, yes, you have a gateway with a single point of failure. I will answer that separately. But at least on the machines in horizontal scaling, you have introduced multiple machines. Even if one machine dies down, you will still have other machines that will keep on functioning. How many of you appreciate that? Horizontal scaling removes the single point of failure. We'll talk about gateway separately, but it removes the single point of failure more or less. Costly. Horizontal scaling is less costly because you can buy cheap machines in high number. High cost of maintenance. No, horizontal scaling has less cost of maintenance. The machines themselves are cheap. How much money that they're going to take to maintain them? They're not going to consume a lot of electricity, etc. So they're going to be having less cost of maintenance. Very difficult to estimate how big a machine do you need. In horizontal scaling, you don't have to estimate because you can buy 2 machines tomorrow. Then you think that hey, I need more machines, you can go and buy 2 machines more. Then you think that you need to buy 2 machines more, you can go and buy more. Now, if your product turned out to be a fad, you can go and sell some of the machines. The remaining machines you can still work with and get your job done. Last, no elasticity of scale. In horizontal scaling, there's a great elasticity of scale. If you think that your load is less, switch off the machines. How many of you are lucky enough to have parents in your home that keep on going and closing all the electricity buttons and say, do you really need this? Do you really need this? Right? So just imagine in horizontal scaling, you can go and just shut down the machines and save on the electricity cost because you don't want to waste money on something that you don't really need. Okay, great. So now all of the disadvantages that you had become advantages in case of horizontal scaling. Does that make sense? On the other hand, the simple architecture advantage of vertical scaling becomes a disadvantage in horizontal scaling because here you have to handle communication between a lot of machines. Okay, just one last point and then we go for a break because I know I might be speaking a lot and you might need some time to recollect yourselves. Just one last point. Till this point in time, we have not delved into the idea that how difficult it is going to be to manage multiple machines, pooling their resources together and getting the job done. How many of you appreciate that? We have not even scratched the surface and we are just assuming that magically these machines will talk to each other, distribute the load, they will distribute the storage and get the job done. The reality is that the remainder of the course, which we are going to stretch over 2-3 months, we are just going to somehow make distributed computing work. So when I say vertical scaling is simple architecture, yes, it is simple architecture. But when you want to introduce horizontal scaling, it becomes insanely difficult. There are so many issues that can come by. Machine 1 and machine 2, they are talking to each other over the network. The network wire got cut. Machine 1 now can't talk to machine 2. So there are insanely high number of challenges that there are going to be when we try to make horizontal scaling work. And that in itself is the biggest disadvantage of horizontal scaling. So even though I've written 5 disadvantages of vertical scaling and 1 advantage, understand that in reality it's a real trade-off. Do you want to select a vertically scaled system or a horizontally scaled system? Is a trade-off that is worth deciding on a case-by-case basis. So don't be horizontal scaling fanboys. Be true to what we are learning in the class, and then on a case-by-case basis decide what we want to select in that particular case. Am I making sense? Yes, Raj, you can do that, but it is going to be a lot more costly and a lot less flexible. In case of horizontal scaling, it's a lot more flexible. Okay. In vertical scaling, resources is limited. That's right, Rajat. But there are going to be several use cases where you want to use vertical scaling. Let me give you a few use cases, and then we'll go for a break. Okay, I want everybody in the class to pay attention. How many of you understand that in case of a banking system, guys, we'll take a break in 1-2 minutes. Let me just say the last few things that I want to say. That let's say I want to build a system where I preemptively know that this is the scale that my system is going to run for the next 10 years. And at the same time, I want very high availability. I want very high guarantees that the system is going to work very fast. Then how many of you think I can choose vertical scaling? Because there is no doubt in my mind that my load is going to increase or decrease. There is no doubt in my mind that I might buy a bigger machine and that machine might go wasted. I have no doubt in my mind that I might buy a bigger machine, but I need not use that machine all the time. In that case, you can go and choose a vertical scale system. You know that your traffic is going to remain consistent. You have a 10-year visibility, and you know that if you buy that machine once, it is going to work very fast. Because if you have multiple small machines, they will have to distribute the compute, they will have to talk to each other. Talking to each other happens over network, which is going to be slow. So in certain use cases, vertical scaling will become a lot more probable. And we are going to understand this more and more as we move on in the course. I'm not going to spend more time on this right now. And Sridhar, let's go on a break. We'll come back and we'll talk about the remainder parts of today's class. Sounds like a plan, everyone? Let's go on a break. Okay, let's go on a break, guys. It's 10:43. Do you guys want a 5-minute break or a 7-minute break? Do you guys want a 7-minute break, a 10-minute break, or a 5-minute break? What works for you? How much time do you want to get back? Okay, a lot of you are saying 45 minutes break. Okay, you want a 45-minute break. Okay, yeah, you can take that. Don't come back in the class, but you can then revise later. Okay, so let's take a 10-minute break. We are going to reconvene at 10:53. I'm going to be Amitabh Bachchan for you and tell you, Devi or Sajano, jayega nahi. Don't go anywhere. We'll meet exactly after 9-10 minutes at 10:53. So see you guys. Don't go anywhere. We'll meet back in some time. Bye bye. my cat with me in my room for at least the next few days because of some reason. I will share that reason sometime later. We don't want to waste the class's time. But please excuse my cat's presence for some days. She also proves this. Only for the next few classes we are going to do that. Anyhow, we are going to have a long winter break. After the winter break, we need not keep the cat with me. But right now, yeah, she has learned HLD. She knows where the which segments are getting covered when. She knows everything. She has been around long enough and hearing all this for quite some time now. Okay, cool. Okay, guys, let's continue. And we are back from the break, I hope. Yeah, she's a she. Yeah, it's free for her. I don't charge her. Actually, she charges me to attend my classes. I have to order some fancy food for her. Yeah, I'm in Delhi. Yeah, it's winter. She somehow does not like not being in my room these days. So she just keeps on meowing when I ask her to go out. So that's why we'll have to be a bit generous towards her and let her stay in the room. Okay, cool, guys. Let's continue. Okay, let's continue, guys. So okay. We discussed before the break vertical scaling versus horizontal scaling. Are all of you able to appreciate that? Can I have a big show of hands by everyone? Can I have yeses from everyone? And yes, we appreciate vertical scaling, horizontal scaling. We appreciate the pros and cons. We appreciate that system design is a bunch of trade-offs. And the first trade-off that we are encountering in our course is vertical scaling versus horizontal scaling. And we are going to keep that in mind. And slowly and steadily, we will understand the pros and cons more clearly about these systems when we understand the ideas more in depth, right? When we understand the depth of the ideas. Okay, great. Now, a few small questions that need to be clear so that you can sleep peacefully tonight. And after we cover those questions, we'll move on to the next topic and try building the idea of how a gateway should develop as a load balancer. So let's go take baby steps and go step by step. First of all, the biggest issue that comes to mind is that even in case of a horizontally scaled system, I said that, hey, you are going to have multiple machines, so there's no single point of failure, because now even if one of these machines fails, you still have a lot of other machines, but there is a big single point of failure in front of our eyes, which is that the public IP is only available for the gateway, and if the gateway fails, then everything will fail. How many of you appreciate that? If the gateway machine is not available, if there's a failure in the gateway machine, no matter all of your internal machines are healthy, but your system as a whole will fail. So I will write this question as, but gateway is still a single point of failure. That's a very valid question. The answer to this, my dear friends, is that gateway is a special kind of a machine whose only or which has very limited rules. So what are the rules of the gateway? Rahul, you're absolutely right. But before I answer that question, let me tell you what are the rules of the gateway. The rules of the gateway is to act as a forwarder. How many of you understand this? Its role is to act as a forwarder. It will forward the request. Second, probably it can have some security related rules. For example, it can have some IP blocking that you can configure. That hey, if a request is coming from this particular IP, then block it because they are not safe, etc. So you can have some security related firewall rules. I hope you understand this, my dear friends. That hey, what all I'm going to allow, what I'm not going to allow. It might help you to rate limit. Now, what is rate limit? I'm going to explain this in the due course of time, but to give you a small idea, think about it this way, my dear friends. How many of you have noticed that if you are making a lot of calls to Google, or let's say, I gave you that example in the last class, right? That if multiple people in your neighborhood are making calls to Google, or your college is making calls to Google, and all of those calls are going from the same IP, does Google start showing you, are you a human page, where they ask you to select which of the photos are photos of cats, which are the photos of dogs, etc. Now, this can happen because Google is doing some sort of a rate limiting, that I will not allow more than X number of requests from a particular IP in a particular duration of time, and that rate limiting can be done on the gateway. And yes, Sagar, it is going to act as a proxy and a reverse proxy. Now, these are very limited roles that the gateway can perform, which means that gateway is not going to be very resource intensive in operation. How many of you understand that? You're not going to run custom logic on the gateway. You're not going to run business logic on the gateway. You're not going to run a very complicated algorithm on the gateway. So the gateway need not have very high compute resources because the job it does is very simple. It need not have very high storage resources because it need not store a lot of information. It just needs to act as a forwarder that I will get the request and forward to somebody else. So the role is very limited. Hence the requirements are very limited. But then to make your gateway highly available, what will you do? You will introduce a good, sufficiently large machine as a gateway, which can handle the load for you, but it will not have to have very good processing capability or very good storage capability. But still the machine with whatever parameters are required nicely should be there. But the major solution to this problem is that gateways exist as active passive configuration. Now, what does that mean? It means that if you have an active gateway machine, you will have one or more passive gateways waiting on the sideline. So let me call it gateway dashed. You will have one or more gateways which are passive right now, which will be waiting on the sideline, that if this gateway fails the health check and this gateway is down, immediately within no time, one of the passive gateways can take its place and start listening on the IP dashed. So I hope you guys appreciate that basically the reason why gateway is important is because that machine is listening on the IP A. Am I making sense? Because that machine is listening on the public IP. Because all the requests from all the world are going to be routed to this public IP. So because that gateway has a very important role of listening on the public IP and being the first point of contact for the outside world, I am going to have passive gateways configured, and the moment the active gateway dies, I will have a new passive gateway become the active gateway, and that new machine will start listening on the IP address. Am I making sense to all of you? The biggest reason why gateways and the biggest way in which gateways are made highly available is by the active passive configuration. That you have one active gateway set up, you have a couple of passive gateways waiting on the sidelines just ready, that the moment we get a signal, we can start acting as a new gateway, and we will not let the service remain inactive for a long amount of time. Am I making sense to all of you? Is the small question out of the way? If the small question is out of the way, let's now focus on the idea of load balancing. So let me explain the idea of load balancing to everybody in my class. And just like everything else, we are going to go much more deeper than the curriculum, and we are going to talk it in a much more detailed fashion. But before that, Nawab has a burning question. Nawab, please go on and ask a question. Feel free to ask a question, man. I'm unmuted you. How will we know if a gateway is down? Generally, we are going to learn something like heartbeat mechanism in the following classes, my dear friends. Just wait for a few more classes. When I teach you the heartbeat mechanism, you will learn how to figure out if the gateway is down. Okay. So Nawab, you were asking that if the gateway is dying at the time when there's an active request that it is trying to forward, in that case, you can't unmute yourself. Okay. I'm not sure why that is the case, but I've given you the permission to unmute yourself. But anyhow, what you're saying is that if there's an active session or if there's an active request that the gateway is forwarding at that point in time and then the gateway goes down, basically it may mean that some request might get dropped off because of the gateway transition. But in the larger scheme of things, if a couple of requests drop out, that's not a problem. Let me ask a question to all of you. How many of you have noticed that you try opening Twitter, but it does not open for you in the first go? How many of you have noticed that? You try opening Twitter. I'm just giving a random example, right? So what is the natural thing that we do? Our internet is working fine, but we try opening Facebook, it did not open for the first time. What is the natural thing that we do? We refresh, we reload, we resend the request, and the next time it will work, which means that in the internet, it is always possible that due to some or the other reason, one or other request might drop off. How many of you appreciate that? So you try opening Scalar, it will not happen very frequently, but once in a blue moon, it might happen that your network was working fine, but Scalar did not open. So what will you do? You will retry. And before even you realize, your laptop, your client, your browser does automatic retries on its own. So if there are some requests that fail off or that fall off due to something wrong going on, but if the system as a whole is not unhealthy, the simple idea is that you do retry, and on the retry, the same thing might actually work. Does that make sense? No, Vinod, I am not saying that I have multiple horizontal machines for gateway. Notice, okay, so there's a confusion. Let me clarify that confusion. I want everybody in the class to pay attention. When I drew horizontal scaling, I said that rather than having one machine, you will involve a bunch of machines or a cluster of machines. Everybody recalls that? Everybody recalls that we discussed this, right? Now, my dear friends, when I draw multiple machines in a cluster, this is different from when I draw a gateway and on the sidelines, I show a passive gateway. These two things are very different. When I draw multiple machines in the cluster, I mean all of these machines are active at the same time. Some requests are going to machine A, some requests are going to machine B, some requests are going to machine C, some data is getting stored in machine D, some other data is getting stored in machine E. So all of them are active at the same time. How many of you appreciate that? So this means active-active configuration, that all of the machines are active at the same time. But when I talk about gateway, I specifically mentioned the active-passive configuration. I never meant that you have horizontally scaled your gateway and now you have two gateways. No, I never said that. You only have one gateway. But if that gateway goes down, there's a passive gateway waiting on the sideline who's right now just quiet, not participating at all. But if the active gateway dies, the passive gateway will jump in and take its place. How many of you appreciate that? There's a difference in the two things. In case of the horizontal scale setup that I showed, this is basically all the machines are active. But in case of a gateway, the passive gateway is just sitting on the sidelines doing nothing. The moment the active gateway fails, it will take its place. So I will not say that I have horizontally scaled my gateways. Does that make sense to Vinod? And does that make sense to everybody in my class, guys? I hope it does. Somebody raised their hand because they had a burning question. I've unmuted them. They can go on and ask their question. But if that, I can hear you. Yeah.
So a gateway is also a machine, right? So let's say a million requests comes in, and our first active gateway goes down.
Right.
So when a passive gateway actually takes the position, that also goes down, right? I mean, they are of similar configurations.
Okay. I never said that the machine is going to go down because of the load that it is facing. We are assuming that you're going to have a gateway which is well equipped to handle the load that you're giving. Now, of course, you can argue that hey, at Google scale, I might have let's say 10 million requests coming to Google at the same time. Probably a single gateway machine cannot handle that. But we'll see that in the following portion of the lecture that there is going to be some sort of a region dependency or regional division or regional sharding that will mean that there will be multiple gateways. But I don't want to go there right now. For now, just imagine that you have a single gateway and that gateway is well equipped to handle the load that you're getting. And if for some reason there was an issue with the machine and the machine goes down, the machine is not going down because of high load. The machine is going down because the machine restarted or there was some problem, physical hardware problem in the machine or some restart was required, etc. In that case, the passive gateway will jump in and take its place. Does that make sense?
Okay, that makes sense.
Thank you, sir. Okay, guys, let's move on to the next topic. In that case, I hope all of you are with me and all of you are enjoying what we are discussing. Rahul, I hope that's a comment. If that's a comment, seems correct. If that's a question, put in the questions tab. I would be more than happy to answer that for you. Now, let's move on to the next topic, load balancing. Now, my dear friends, I will want to start my explanation by clarifying one misconception. Guys, a lot of Didis and Bhaiyas of the world will teach you that the gateway machine that you have, that gateway machine itself has the responsibility of load balancing. But that's not the truth. The truth is, gateway is one responsibility. Load balancing, gateway is the responsibility of acting as the bodyguard or acting as the guard of the society that everybody who wants to come will first come to me and I will forward. Load balancing is a different responsibility. Load balancing basically means I'm getting a lot of requests. I have 10 machines before me that can handle my requests. I will forward some requests to machine A, some requests to machine B, some requests to machine C. How many of you understand that these are two different ideas? The idea of gateway or the function of gateway is to be the first point of contact. That anybody who will send a request, they will first come and talk to me. The idea of load balancer is that I'm going to distribute traffic. If I'm going to get 100 requests, I'm going to send some of them to A, some of them to B, some of them to C, some of them to D, some of them to E. Am I making sense, guys? These are two different functions. Load balancing and gatewaying are two different functions. For now, we can consciously understand that the same machine, physical machine that is acting as the gateway, can double up and play the role of a load balancer. So notice what I'm writing. I'm saying that the same machine is acting up as a gateway and doubling up the responsibility by acting as a load balancer. But these are two different functions. Am I making sense? You will not assume that the gateway is the one that is going to load balance. But in most cases, the same machine can be used to do both the functions. Am I making sense? These are two different functions. Gateway is the entry point or the first point of contact. Load balancing is the function of distributing traffic. Two different functions probably can be performed by the same machine, but two very different functions. Is that clear to everybody in the class? So, so basically you are having a load balancer logic also written on the same machine, which is acting as a gateway. So now, if this is what the machine is, then it will act as the first point of contact. This is the machine which is running the public IP. And when the request comes, it will do some logic internally and figure out of the multiple machines of the cluster, which machine do I need to forward the request to? Is the idea clear, guys? So the responsibility of dividing the traffic is with the load balancer. The responsibility of acting as the first point of contact is basically on the gateway. So let me write down. Gateway has the responsibility of acting as the first point of contact, and load balancer has the responsibility of acting as a distributor of load. Will all of you remember this always, my dear friends? These are two different responsibilities. Does that make sense? Sagar will see that in the following classes. Once we go to microservices, I will show you how different machines can play the role of a load balancer and how different machines can play the role of a gateway. But right now, let's not go there. Rahul has a question. The gateway will help you for discovery and load balancer will help you with the distribution of traffic. So by discovery, Rahul, do you mean discovery of services or do you mean discovery by the external clients that, hey, this is the first point of contact for the service? No matter whatever you mean, the answer is a yes to both of them. So your comment is absolutely correct. Okay, guys, I hope everybody's with me. Now, let's build on top of this. I want everybody's complete attention. It's 11:13. I'm going to roughly teach for 25-30 minutes more. It's the last leg of the class. Just refresh yourself, drink some water, and let's be with me for another 20-25 minutes or 25 minutes or so. Okay, so what do I want to teach you? I want to tell you that there can be two kinds of clusters, and each kind will require a different class of load balancing. So I'm saying that there are two kinds of clusters that there are, and each of the two kinds will require a different form of load balancing, my dear friends. Now, what does that mean? Let me show you what does it mean. Let's first of all talk about the stateless architecture. I want everybody in the class to pay attention. This is very simple. Stateless architecture. What does stateless architecture mean? Okay, I have a gateway machine. Beyond that gateway, I have some machines where my code is running. Now, all of these machines are part of the same cluster, which means the same piece of code will be running on all of them. So the same code which is running here, the same code will be 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 running here. Now, let's assume that I am building an application like a calculator. So whenever a user sends a request, the client's request will be something like, can you please do 7 plus 10 for me? Now, given all of these machines are running the same code, I can argue that all of these machines in the cluster, so let me write down this as well, all of the machines in the cluster are equally well equipped to handle any query. How many of you understand this? So I have a 7 plus 10 as a query that is coming from the client. All of these machines are running the same code. The gateway will act as and develop as a load balancer. And now this load balancer can, based on its own whims and fancies, can forward this request to any one of the machine without any concern. How many of you understand this? If all of the machines are running the same code and the operation is such, which is just a 10 plus 7, now remember the word, it is a stateless architecture. Now, this might look obvious right now, but the word stateless is going to be a key point because when I will draw the second architecture, it will not be stateless. So remember the word stateless and just understand what I'm saying. There's no need for you to understand the word stateless just yet, but when I go to the second example, then the stateless will become important. But for now, just look at the example. I have a client that sends a request. The request can be 7 plus 10, 10 plus 7, 7 minus 5, 10 plus 15, or any random request. Or let's say it's not a calculator service, but it's a weather service. So people are going to make a request that, hey, can you please tell me what is the weather in Delhi, or what is the weather in Mumbai, or what is the weather in XYZ place? So the request can go to any one of them. Guys, can give me a minute. There's an important call from office. Somebody from office reaching out to me. Probably there's a Sev1 or something, or Sev2, something like that. Give me a minute. Let me just take the call, then I will continue with the class. Just give me a minute, guys. Hey guys, I'm back. Can you hear me? Can all of you hear me? Can all of you hear me? Okay, great. So yeah, there was something that the team is stuck in. They wanted my help. I have shared the guys, can you hear me? Can you hear me now? Cool. So we are all set. Let's continue with the class. And no, I'm not on call, but there is the on call actually called me because he needed some help in how to debug a particular thing. I've shared my opinion, and I will join the call after I end the class. Okay, guys, let's continue. So we're talking about that. Hey, there can be examples of services which can be stateless, where the particular request can actually go to any one of the machines. There is no reason why it needs to go to a particular machine. All of these machines are running the same piece of code, and all of these machines are equally well equipped to handle any kind of a query. Does that make sense, everyone? So now, what are the strategies that this load balancer can employ? Let's think about that. Now, guys, are you still with me? Are you hearing? Are you not sleeping? Okay. So what are the strategies that can be employed by a load balancer to balance load in a stateless architecture? So notice the heading. What are the strategies that can be used by a load balancer to distribute the traffic in case of a stateless architecture? The aim of the load balancer is that if I have 10 machines, I should be equally distributing my load so that my overall throughput can increase. How many of you understand that? Because if I just overwhelm one machine and the others are just enjoying their life, then my overall system's optimization will get compromised, right? So I want to equally burden the machines so that I can handle good amount of load nicely. That's the optimization curve that the load balancer has. Now there are a bunch of approaches here. Because it is stateless, I can do inky, minky, ponky, and forward it to anybody. Nobody's going to come and ask it to me. The first strategy that comes to mind is round robin. How many of you understand this? That the load balancer can forward the first request to A machine, second request to machine B, third to machine C, fourth to D, fifth to E, and if I have 5 machines, the sixth request can again go to the first machine. How many of you appreciate that? But I can do round robin. The first request can go here, the second can go here, the third here, fourth here, fifth here, and the sixth again will go here, and so on and so forth. Now that's great. One strategy. The second strategy that I want to say is that there can be a reality that not every machine is of equal capability. How many of you understand that? Because distributed computing or horizontal scaling allows you to add machines whenever you want to. 2D machine layout although, right? So you don't have to go and buy very important, very critical, very beautiful, very beefed up machine. You can go and buy a random machine, a commodity hardware, and plug it in, which might very well mean that out of the 5 machines that I have, 3 of them are new generation machines, 2 of them are old gen machines. The 2 machines that are older might be able to handle lesser load, and the 3 machines that are bigger might be able to handle more load. How many of you appreciate that? So let me write down, before I mention the second strategy, let me write down a note. The note that I want to write, it is possible that all machines may not have equal resources. Is this clear, everybody in my class? It is possible that not all of them have equal resources. Now, if all of them don't have equal resources, guys, then tell me, would round robin be the best strategy? Because you are distributing equally to all of them. Do you think that is what you should do? Because if you're distributing equally to every machine, then you are underwhelming the machines that are of new gen and you're overwhelming the machines that are of old gen, right? So what you should do something like a weighted round robin. What is meant by weighted round robin? Weighted round robin means that you are going to distribute traffic in a round robin fashion, but for every new gen machine, you will send them, let's say, more number of requests in the round robin, and for every older machine, you will send them less requests. Is that logically clear? This is all beyond the curriculum. I'm just explaining it to you. No need to go deeper down into this. This is very logical. It should be clear. The third kind of a strategy for load balancing in stateless services can be something like least connection first. Now, what is the idea here? My dear friends, not every request is going to be equally heavy. How many of you understand that? Let's say I have a user, Jitendra, who's a very power user of Instagram. Jitendra opens his Instagram all through the day. He wakes up, he opens Instagram. He goes to office, he keeps on looking at Instagram, posting photos. He goes to the loo, he keeps on watching Instagram. And all day, till he sleeps, he's watching Instagram. Now, he's a very power user. He adds a lot of fun posts. He keeps on recording reels, putting them. And on the other hand, there is a Chanchal in our class who never uses Instagram, right? She or Chanchal actually just opens Instagram once every 7 days. So they might not be a very heavy user of Instagram. Now, tell me, my dear friends, if both of these users who are very different individuals send a request to Instagram, please load my profile. Do you understand both of the requests will be taking equal amount of time of processing or equal amount of processing required? Or do you think the person who's a very heavy user of Instagram will take a lot more time to process their data, and somebody who is a very seldom user, probably there is less data to process? How many of you understand that not every request is going to be of equal size and equal requirement? How many of you appreciate that, guys? Right? Which means that round robin or weighted round robin might not be the best strategy always. You can also employ something like least connection first. What does that mean? It means that you are going to keep a track. As a load balancer, you're going to keep a track how many you're going to keep a track. Okay, guys, just a minute. I actually got an incident also. Okay, I will join the incident after some time. Let me very quickly complete the class. So you can have a least connection maintained at the load balancer. The load balancer will keep a track as to how much time or how many pending requests does this app machine has. How many requests does this machine have pending? How many requests does this machine have pending? The machine which has the least amount of pending requests, I will forward the request to them. Am I making sense, guys? Am I making sense? So this might be a strategy that you might employ, least connection first. There can be several other strategies which are for the stateless load balancing, but the idea remains the same, that the load balancer can do inky minky ponky. The load balancer can just somehow forward the request. Because it is stateless, all of the app servers are equally well equipped to handle the query, and hence will be able to easily distribute the traffic. Is everybody happy with this approach? This is where I want to end the stateless load balancing. And now I will just introduce the next topic to you, and I will end the class. I will not overwhelm you. I will just introduce one more topic, and then we'll end the class a bit early today. I also have ICM calls to attend. So I'm just going to introduce one more topic, give you the time to go back and sleep. One topic of today's class will remain pending, and I will cover that in the next class. Sounds like a plan, folks? And whenever I think I need to have an additional class, I will take additional class and cover that. So consistent hashing will remain pending after today's class. I will cover that in the next class. I hope that sounds like a plan. Cool. So now let's introduce to you the second form of architecture that there can be. The second form of architecture, my dear friends, can be called as a stateful architecture. So notice the words, everyone. The previous architecture was called stateless architecture. This architecture is being called stateful. Everybody noticing the words? Previous one I called that stateless. This time around I'm calling it stateful. Okay. So what does that mean? You have a gateway. The gateway, let's say it is doubling up as a load balancer. There's IP address, public IP on which that gateway is listening. You have a bunch of machines in the backend. All of the machines are running the same code. Just like in the previous example, in the stateless example, in stateful also, all the machines are running the exact same code. Guys, are you with me? All the machines are, because they are part of the same cluster, they are part of the same organ. So all the cells of my heart are going to be similar in nature. All the cells of your brain are going to be similar in nature, which means all the machines of this cluster is going to be running the same piece of code. Great. However, all of these machines have some individualistic data that you are storing there. Let me give you an example. How many of you have chatted with ChatGPT? How many of you have used Gemini? And this is just one example that I'm giving today. In the future classes, you will see how this might be more and more prominent. So when you talk to ChatGPT, let's say Sai Prasad, you talk to ChatGPT, you open a previous conversation. Do you think that conversation, when you type the new message, ChatGPT already has the context of the entire conversation and they will reply based on the context that they already have? Or do you think they will forget the context? How many of you understand that ChatGPT will remember the context of the chat thread active? They will not forget. Is that clear to everybody in the class? Is that clear to everybody in the class that you are going to remember the context of the conversation? Now, my dear friends, let's say there is a user. And let's say this client is, let's say, Krishna. Krishna is a client. He is talking to ChatGPT. He sends a hi. Let's say Krishna is user ID 107. And let's say Krishna's request goes here. Now he says a hi. So you know that, okay, you run a model. You say that Krishna said a hi. The model ran and let's say generated a hello. So this hello was returned back to Krishna. And Krishna now knows that, okay, I got a hello. Now, probably, just to make it slightly more clear, I hope all of you understand that whenever a model is running, it essentially means, my dear friends, that you are essentially having some model and then running inferences on top of it. And because of the inferences that you're running, you might be creating some weights of the context or some vectors of the context that you are collecting. How many of you understand that? Because the model needs to understand that, okay, I already have a conversation, hi, hello, with Krishna. Now, if Krishna, after receiving a hello, says, I am bored. This is the next message that Krishna sends. Tell me, guys, if this next message, the load balancer forwards to this machine, will this machine be able to know the context of the conversation? Do you think a completely different machine, even if it is running the same piece of code, will a completely different machine be aware of the context of the previous conversation that has happened between Krishna and ChatGPT? And do you think this machine will be able to do justice to this request? I want everybody in my class to answer this. Do you think this new machine will be able to do justice to this request? No. Which means that this new request also of Krishna should somehow land in the same machine. The I am bored message should land in the same machine so that the same machine which knows all the context can do the processing and reply back with a message. How many of you understand this? This is an example of a stateful architecture. That even though all the machines are running the same piece of code, even though all the machines, Nawab, yeah, that's one example, but we'll see more examples in the following classes. But basically, even though all the machines of the cluster are running the same piece of code, but still your architecture is stateful, which means that whenever a new request comes to the load balancer, not every machine is equally well equipped to handle your query. Only a certain machine is well equipped to answer your query, and hence the load balancer needs to forward the request of a particular user ID or a particular request ID to a particular machine. The load balancer cannot do inky minky ponky. The load balancer cannot do round robin and forward the request to a random machine. Have I explained to you the difference, my dear friends? Let me write it down so that everybody can get some time to internalize what I'm saying. So I want everybody in the class to look at it, right? And let me take a different color pen so that you feel a bit more interested in reading what I'm writing. Okay. Okay, this is very light. I should not take it. Let's take this one. In stateful architecture, even though all the machines of the cluster are running the same piece of code, but still, for every new request, not all machines are equally well equipped to handle. How many of you understand this, my dear friends? Even though all the machines are running the same piece of code, Vegulam, don't you think that you are making a very strong argument and questioning the entire point of the stateful architecture? I think you should wait for some time and see how beautifully this will emerge, and this will actually be a very real use case that we'll be using. Okay, so always, I understand that right now you might have a bunch of questions, but appreciate that with the class progressing forward, you will see that how beautifully a stateful architecture can actually become very, very helpful. Okay, so let's come to that. Anyhow, let me repeat what I'm saying. In a stateful architecture, even though all the machines are running the same piece of code, my dear friends, still a particular request is better handled by a particular machine, which means that there needs to be some way in which the load balancer knows that this request I will always forward to this machine. How many of you are with me, my dear friends? How many of you are with me? There needs to be a way for the load balancer to keep the memory that this request ID I will always forward to this guy. Okay, Nawab, that's not entirely true. I will teach you as I move along. Now there's one thing that I'm reading again and again in the chat, and I think it's important that I clarify that. Some of you are thinking that, hey, you are having a TCP connection from the client directly to the end machine. The answer is no. The connections are being maintained by the client till the gateway. Then the gateway is forwarding a request internally to an internal guy. So the outside world is not directly talking to the internal machines. Does that make sense, Sagar? So there's no TCP connection between the outside world and the internal machine. Remember the private network idea. The outside world is only going to talk to the edge machine. The edge machine is going to forward the request internally, get the reply back, and act as if the edge machine is replying and reply back to the outside world. So your understanding is slightly wrong, and I think I've clarified that. I think you are now with me, you understand it. But I want everybody in the class to pay attention that somehow the stateful architecture, the load balancer needs to have a way to know which request to forward where. Is that clear to all of you? So something like probably the load balancer, and I'm saying probably because this is not the right answer, but something like probably the load balancer will keep a track that if a request from 107 comes, I will forward to machine C. If a request from 220 comes, I will forward to machine A. If a request from user 660 comes, I will forward to machine D. So whenever a new request comes, probably the load balancer can check in its table and forward the request to the correct guy based on the information that the load balancer has. Guys, am I making sense? This is an anti-pattern. This is an anti-pattern. This is not a good solution, but I will leave my class at this point today that somehow, let me write it down so that all of us are on the same page. Somehow, the load balancer needs to know which request to forward to which machine. Now, in the next class, I will teach you what is the right strategy to get this done. Nawab, yes, but that's not entirely correct. Okay, guys, I hope you guys enjoyed the lecture. This is where I will stop the lecture at 11:38. So okay, can I repeat anti-pattern? Kiran Kumar, I'm saying, do you appreciate, Kiran Kumar, that somehow the load balancer needs to have a map or some logical way to figure out which request to send where? Am I making sense, Kiran Kumar, at least there? That the load balancer needs to have a logical way to figure out which request needs to go to a particular machine. Because I can't be doing inky minky ponky, I can't be doing round robin. Because I can't do round robin, load balancer somehow needs to keep a track of which request to send where. One very brute force approach can be that the load balancer will maintain an entire table that which request will go where. But if the load balancer starts doing that, the load balancer will become very bulky. The load balancer will have to store very big amount of data. Kiran Kumar, is that right? And that I'm calling as an anti-pattern. Even though this looks like a brute force solution, but this is not the right solution. And in the next class, I will tell you what is the right solution. Does that make sense? Okay, guys, thanks a lot, everyone. I hope you guys enjoyed the lecture. I enjoyed teaching you. I understand some of you might be having concerns that Tarun, you teach too much. Some of you, Rahul will see what is the solution in the next class. I don't want to break the fun. So wait for the next class, my dear friend. Okay. Some of you, let's talk a bit about a few minutes on how the batch is going. Some of you might be worried that this is too fast. Some of you might be worried that this is too slow. But a big portion of you would be happy with the pace. Guys, let me know your feedback. How do you think? Are you enjoying the classes or not? Based on your individual feedback, I will try to accommodate more and more people going forward and change and probably improve how we can conduct these classes for this particular batch. So your feedback is going to be very, very essential. Please let me know what you think. Please let me know what you might want to change. Please let me know what you want to keep the same. And my hope is that you guys are learning from the module. And my request is going to be, please keep on attending all the lectures. I can guarantee you today that this is going to be one of the most impactful module that you're going to be a part of in the entire Stereo curriculum. It comes very late in the day. You have already attended multiple classes by now, multiple modules by now. But trust me when I say this is going to have a very big impact in your career trajectories. You have paid lakhs and lakhs of rupees to Scaler. If you really want to make that money worth, please don't skip this module. Be a part of this module and make the most out of it. So that's my submission to all of you. All the very best. Anybody who wants to drop off can drop off. And I would want to see you all. I would love to see you all in the next class, which is going to be on Friday. Okay. So now I'm going to pick up all the questions one by one. Thank you for the kind words, Neha, and thank you for the kind words, Sabir. I'm going to now pick up the questions in the chronological order. Anybody who wants to ask anything can add a question in the questions tab. I would be more than happy to take your question one by one. Krishna is the first question that I see. Question from Krishna. Please suggest if all the sessions for HLD are going to be theory based, or are we going to do some practical sessions also, like creating load balancers, Kafka systems, etc. So my dear friends, understand it this way. High level design or system design is a study where you need to understand how systems are actually built. So you need to understand how systems are architected, what are the trade-offs involved, how do you take the right decisions. All of this involves a lot of understanding of the theory. Now, these are not theory sessions, to be honest. These are real practical ideas that I am teaching you in a 3-month-long module, that tomorrow all the systems that you're going to build, you're going to leverage the same ideas. I'm not teaching a theory. I'm not sure why some of you would feel that way. Think about it. Do you think I'm opening a book and I'm teaching the first topic and then I'm moving to the next topic? No. I'm trying to chip off a real practical knowledge and break that down into smaller pieces as to how you would think about architecting systems that can scale. With respect to the hands-on of this, you should actually attend the project module where you can implement hands-on solutions, where you can leverage all this information. But system design in your companies, in your interviews, are always going to be how do you take the right decision and architect it the right way. And with LLMs, this is going to become more and more critical as coding has become a commodity. Your LLMs can code things for you very easily, but you need to be the one who can decide the architecture of the system, and this is going to be very, very critical for all of us in the coming future, and even it's critical today. But having said that, in our batch, in our course, in my module, I am going to take at least 10 different real life case studies. For example, I will pick up a case like Hotstar, that if I want to build a Hotstar tomorrow, what are the components I will build? How will those components look like? How will a component 1 talk to a component 2? I will talk about real life cases and tell you how to build them. But do we go on and code this up? No, that's a hands-on exercise that you can do in the project module. I hope that answers your question, Krishna. Thank you for asking. The next question is from Neha. But before I move on, right, for those of you who have any doubt on the use case of HLD or the advantage of system design, feel free to ask that question to me as many times as you want, and I will be more than happy to impress upon you that the importance of this module is so much that no other module can compare with respect to the importance. So ask me as many questions as you want to, ask me as many doubts as you want to there, and I will be more than happy to resolve your doubts there. Neha's question is the second one. In case of horizontal scaling, do all the machines need to have the same configuration? So my dear friend Neha, I told you that in horizontal scaling there will be multiple clusters. Every cluster will have the same piece of code running on them. Every machine of the same cluster will have the same piece of code running on them, but every machine of the same cluster might have very different configuration. I think Neha, your question would have gotten answered in our due course of the class itself, when I would have told you that hey, a different machine might be more powerful, a different machine might be less powerful. So I think your question is already answered. Next question is from Chanchal. Which commands are required and how we can check CPU utilization, any issue with memory for application, any resource? Okay, my dear friend Chanchal. So there are two ways and two abstract levels to look at this problem. One is a particular machine's CPU utilization, particular machine's memory utilization, particular machine's active sets, etc. There are going to be very, very common, very easy terminal commands, command prompt commands, PowerShell commands that you can run on the operating system that you're running and figure out what all threads are running, what is the CPU utilization, what is the memory utilization. You can simply Google and you will find a list of commands for your platform. But the second thing is when we look at from a architecture level, that I have 1,000 machines running, what is the average CPU utilization across the 1,000 machines? What is the average memory utilization across the 1,000 machines? That is something that I'm going to teach you as part of observability discussion in the microservices class. So you have to wait for that. For a particular machine, the commands that you're going to require, you can very easily Google them and read them. From a larger architecture point of view, we are going to cover that in the following classes. Next question. Do we ever face the need for multiple clusters as well? Abhishek, the answer is yes. The best analogy would be we have a human body. Do you think only our heart forms a human body? The answer is no. We need a brain, we need a heart, we need muscles, etc. etc. So yes, there are going to be multiple clusters that are going to be required, and this we are going to see in real life in the following classes. So wait for some time, my dear friend, and you will get the answer to that. Shilpa has the next question. Apart from the notes that you're writing, and my handwriting is very bad, I know that, but do you also provide another set of notes? I do. I have taught this module now probably 30, 40 times, probably 30 times at least, or 20 times at least. I've taught it many times. I don't know the exact number, but I've taught it many times. So I have over the last few years created my own set of notes booklet where I take a common notes booklet from the last batch, and then whatever new things we cover in the batch, I keep on adding those things in the note booklet. That notes booklet today is roughly 120, 130 pages large, and with every new batch, it increases in size. So I am going to share a note booklet in the next few classes with you for your batch. After some time, you can print it out, keep it under your pillow, and sleep over it every day. And that note booklet is going to be super, super helpful, my dear friends and Shilpa. So wait for me to share that notes booklet in the next few classes, and that notes booklet is going to be very, very helpful. Please keep it closer to you. The next question is from Kiran Kumar. We should understand CS fundamentals better to learn HLD. My dear friend, no, Kiran Kumar, of course, that's a good thing. But I teach in a manner where I don't assume many prerequisites. Whatever I think is needed, I will be covering in my own discussion, my own batches. And on the side, you can learn more about CS fundamentals, but there is no reason why you would want to stop HLD classes and first learn CS fundamentals, because I teach in a manner where I teach everything that might be required for understanding the concept. So I think you would be good there. Firewall or routers are gateways? No, my dear friend. Firewall and routers are firewalls. Routers are routers. Firewall is a concept which can be applied on any machine. Gateway, my dear friend, is a special kind of a router. So if you have a backend system, the first point of contact for the backend system, which is actually a router, is going to be a gateway. So gateways can be thought of as a specialized router. Okay. Is there multiple active gateway or single? The active gateway is going to be one from what we understand today. But going forward, when we are going to look at multi-region setups, then there are going to be multiple active gateways as well. But think about it like this way. For one backend, one active gateway. If this product itself has multiple backends, then for every backend we'll have a different gateway. But for one backend, one active gateway. Does that make sense, my dear friend? Thank you. Next question is from Chinnari Ishwar Prasad. The question is, which system will help in switching between the gateway? So there would be a heartbeat mechanism. There would be things like an orchestrator, a zookeeper. We're going to learn about that towards the mid of the module. But there are going to be an orchestrator which is going to help you in switching to the new gateway. Next question is from our friend Chinari again. If a request is coming in, will gateway or load balancer decide which machine to forward? I guess, Chinari, my dear friend, your question should be already answered. But if not, let me answer that once again. The gateway is the machine that decides which request to forward where, because it is going to do the load balancing. The gateway decides which where should I forward it. So if you are confused whether the forwarding is a job of the gateway or the load balancer, you will remain confused for the next few classes unless until I draw a diagram where I draw separate load balancer and separate gateway. For now, given that both of the functions are being performed by the same machine, this doubt will remain for some classes. If that was your doubt, then whether the load balancer does the forwarding or the gateway does the forwarding. If the question is that, wait for a few more classes. But overall, you know that yes, load balancer and gateway will forward the request to the right machine. The load balancing strategy is going to be done by the load balancer. Okay. Next question is from Kiran Kumar. How do you stay calm when there is a priority issue? How are you staying calm? So I did give some feedback to the individual who is triaging it right now. But yes, I need to rush to that call. So I will try to end the class quickly. So yeah, I do have a long night in front of me probably. So I look happy, but I'm not happy. Pradyuman says, can stateful be converted to a status by using DB's cache, etc.? Pradyuman will see that in the future classes, my dear friends. Yes, that's a good idea. We'll see that in the following classes, my dear friend. We don't have enough understanding today to answer that question for you. Okay, we'll build that understanding over the next few classes. The next question is from Yash. Is gateway and load balancer tied to each cluster? No. So my dear friends, this is for the entire backend, and we are going to see when we build multiple clusters how the load balancing will happen. But at least the gateway is tied for the entire system. Okay, Yash. The load balancers can be different for every cluster. Can you explain some basic things like bit rate and network card? Damab, that is actually going to be beyond the interest of our class. I'm not going to spend time on that today. Go and read about it. If you have a doubt, ask me. But not very interesting to the flow of what we are learning in the module. So these are very small things like what is the bit rate, what is the network bit rate, etc. You can learn about it. If you have any question, you can come back and ask me. My LinkedIn profile, I think I'm not that difficult to find online unless until you argue that you have grown so old that you don't match your LinkedIn profile photo. If you say that, I will be sad, but yeah, that's my LinkedIn profile. I'll just share that. The next question is from Shiva. I have a question in stateless. How load balancer know if it is a heavy user or not? If we apply this logic to load balancer, then is it an extra responsibility? Okay, good question, Shiva. The load balancer need not know whether the request is coming from a heavy user or the request is coming from a non-heavy user. Okay, Shiva. The load balancer need not know. What I said was an approach called as least connection first. In that request, my dear friend, what we did was the following. We said that if this is the gateway and this machine doubles up as a load balancer, then whenever a request comes, I will not have any magical way to figure out whether that request is coming from a heavy user or a light user. But what I will do, I will check or I will know for all the machines in my cluster, what is the pending request on each one of them. So load balancer knows that this machine already has 4 requests that it is processing, which it has not replied back to. This machine already has 6 requests that it is processing, it has not replied back to. This machine already has 1 request that it is processing, it has not replied back to. The other request it has already replied back to. This machine has 7 pending, this machine has 2 pending. Now if I know this information, the next request, which might be from a heavy user or light user, I will easily forward that request to this guy because this guy has the least number of pending requests. The idea being that whichever guy was unlucky enough to get requests from heavy users, that guy will keep that request pending for a longer amount of time, and hence you are going to discourage the load balancer to send that machine more requests. So the idea is the load balancer only tracks how many requests are pending on each one of the machines. It does not have any magical wand to figure out whether the request is coming from a power user or a non-power user. Vertical scaling is used for small resources, small projects, and horizontal for large resources, big projects. No, that would be a very big generalization, my dear friend, and that is not the right generalization, my dear friend Ajinkya. Wait for some more classes. You will see that how this gets sorted out. But that's a wrong generalization. Always stop yourself from making very big claims in system design because there are lots and lots of scenario-based approaches that are going to land you in different places. So I will for now say no. It's a no to your statement. That's not correct. Wait for more classes to understand this better, and you will understand when to use horizontal scaling, when to use vertical scaling. Kiran Kumar, is it possible to crack Microsoft after having 10 plus years of experience in the service companies? Absolutely, my dear friend. In my own larger team, I have many engineers who have worked in their life mostly for service companies, but then they join laterally Microsoft or companies like Microsoft, and they do very good. So the answer to your question is absolutely happens all the time. Okay, guys, I think we should end the lecture. It's 11:57. Thanks a lot for attending the lecture. Thanks a lot for being with me. I hope you guys enjoyed the lecture, and I hope to see you all in the next class. Okay, Ashish has raised his hand and has posted a question. I will very quickly take that question also. Ashish is saying, after deep reflection, I made the difficult decision to step away from a job as nearly 10 hours, 12 hours are being wasted without meaningful learning or skill, affecting my health and peace of mind. I'm now chosen to invest that time in myself. Okay, Ashish, that's a very loaded question, right? And that's a great way to keep me back in the class, right? Because I can't ignore a question like this. So my first question, let me actually unmute you, and we'll have to be quick because, as you know, I have a SEF2 which is waiting for me. But hey, Ashish, can you unmute yourself very quickly? The first question I want to ask you, my dear friend, is: have you already left the job, or are you about to leave the job? What is the scenario? If you can confirm, you would have gotten an option on your screen to unmute yourself. Please click on that button, and we can have a chat. If you don't see that option, let me try and give you that option once again. So I'm giving you that option once again. Please see on your screen, you would see a button to unmute yourself. Use that button, and let's talk to each other. Okay, I can't see you speaking even now. Ashish, can you reply on the chat? If you can't speak, can you reply on the chat whether you've already left the job or are you going to leave the job? Okay, I am not getting a reply. So I will assume something and answer that for you. Hey, Ashish.
Hello.
Hey, Ashish, hi.
हेलो सर सॉरी सर मैं सर आपको बार बार डिस्टर्ब कर रहा हूं सर मैंने छोड़ दिया सर तो मैं नहीं कर पाऊंगा मैं अभी अपने आप के ऊपर पूरा फोकस करके सर नेक्स्ट इंटरव्यू करना चाहता हूं मैं
I now remember that we had a conversation in the last class also. Okay, that's your decision, Ashish. I respect that. And yeah, I wish you all the very best. That's all I can say, right? So
सर नहीं मेरा आपने जो बोला था ना वो 2-3 दिन मेरे दिमाग में घूम रहा था मगर सर मैं नहीं बेयर कर पा रहा हूं सर वो जो कल्चर है ना तो मैं
Ashish, the only concern that I had is that your resume will make it difficult and more difficult for you to land interviews going forward if you don't have experience to show for after your graduation. But if you've already taken the decision and you already left the job, then no issues. We will try to maximize the opportunities as they come. So no issues.
बस हां सर वो कोई इशू तो नहीं है आप मेरे को डरा रहे हो सर यार अब बोलो
मैं तो सच मतलब I'm sharing what I feel, Ashish. I might be wrong. down. And at the same time, I'm not saying that that's the end of the world, right? Or I'm not saying that hey, you don't have any option. But on in my view of things, when you have an option to either continue or leave, I would have preferred continuing based on what I understood from your side.
वो सर बहुत ही लाइक मैं नहीं से सकता सर, आप समझिए थोड़ा, मुझे लाइक वो बहुत 1 साल का भी था एंड प्लस वो 8,000 रुपीज पैसे तो मतलब ही नहीं है, मगर जो वर्क कल्चर हो गया, जो चीज का नाम मैं सोचा कि वो 12 घंटे दिन से मैं अपने ऊपर 18 घंटे दूंगा, चेंज नहीं सो पाऊंगा, अपने ऊपर काम कर पाऊंगा, मेरा वो प्रायोरिटी सबसे इंपॉर्टेंट अभी के सिचुएशन में वही है।
Makes sense, Ashish. I think this makes sense what you're saying. So
नेक्स्ट इंटरव्यू के लिए बहुत अच्छे से प्रिपरेशन करूंगा, अपने ऊपर काम करके, लाइक कुछ ऐसा तो नहीं है, ऑप्शन ही नहीं है मेरे पास, ऐसा तो लाइक एंड
नहीं, ऐसा कुछ नहीं है. Of course, you have options. And yeah, I wish you all the very best. I hope that you get a good job very soon.
थैंक यू सो मच सर, थैंक यू सो मच,
Thank you. Okay, guys, thanks a lot, everyone. See you again in the next class, guys. Bye bye. Good night. See you on Friday. Bye bye.